This is Mr. Clever Maths. This is your Higher Applications of Maths Ultimate 2025 Exam Prep video. I hope it goes through every single topic, every single question that I can possibly come up with that will prep you for your Higher Applications of Maths 2025 exam. And if you're liking this content, consider joining this channel because I am going to be giving you an exclusive live stream on the day before the exam. That's right, on the Thursday the 15th of May at 7 o'clock, I'll be doing an exclusive members only live stream for Higher Applications of Maths, lastminute.com basically for you there. £4.99, just click and join. Clever Maths is sponsored by Lecky, the educational publisher for Scotland. Today we're going to look at practice workbooks for National 5 and Higher Maths. These are just £5.59 when you use the discount code CleverMaths at leckyscotland.co.uk, and these are excellent because they have lots of questions topic by topic by topic. So as you're working through the year, you can revise and practice any topic you want and make sure you are comfortable with that topic. But also when it gets towards exam season, a practice exam paper right at the end to make sure you're ready for your exams. Just £5.59 when you use the discount code CleverMaths. The links are in the description and down below. Question 1. Bailey takes out a loan for £4,000 with an effective rate of interest of 29.9%. Calculate the monthly. So to calculate a monthly, if it was in a spreadsheet this, we would do 1 plus the box to the power over 12, and then we'd take away 1. But then we need to times by 100 really to get the percent. But the Excel does that for you, but we're going to do it manually. So it's 1 plus 29.9, 2299 to the power over 12. Now, if you can't get there yourself, there's a calculator. 100 plus 29.9 divided by 100 gives you 1.299. And it's a power over 12, not divided by 12. And then you take away 1, because I want to get rid of that 1. And I want to times by 100 to get back to a percent. So 1.299 to the power of 112. Take away the 1, times 100, and we get 2.20389. 2.20389, and a lot of you probably round that to 2.2%, which is what I'll do just to make it easier next time. So there we go. Part B, Bailey makes level monthly payments of £250 at the end of each month, complete with loan schedule. So we can do our working if required, but we're going to use a calculator for most of this. So we're just going to do it all in the calculator. So first step, 2.2%, that is 0.022. Or you can just times by 2.2 and divide by 100. To get the interest, you do loan outstanding times the percent, which is 88. Capital is 250 minus interest, 162. And loan outstanding is loan outstanding before minus your capital, which is 3838. And then we start again. So we want the interest, so it's 0.022 times 3838, 84.436, so 84.44. And then we want the capital, 250 minus 84.44 is 16556. And then the loan outstanding, 3838 minus 165.56, 367244. And we're done there. Higher Applications of Maths 2022 question 1. Jill borrows $56.50 from a bank. Annual effective interest rate is 9%. Jill makes level monthly payments of 18601 at the end of the month. Complete the loan schedule for Jill's loan to show the loan outstanding at the end of month 2. So first of all, we need to work out the monthly interest. So we turn that 9% into 1.09. 100 plus 9 divided by 100. So it's 1.09. And it's the power over 12 because it's 1 month. So if I do that in a calculator, you'll see that I get 1.09 to the power of 1 over 12. That's 1.0072. So we then need to obviously take away the 1 and times by 100 to change it back to a percent. So I need to take away 1 and times by 100. So there it is there. Take away 1 times 100. and we get 0.720732, 0.72%. Now, when you're doing your table, you can use 0.72%. You would even get away with 0.7% of the full amount. I'm just going to use 0.72 because it's easy to do the sums in a calculator than having to keep this one going the whole time. Just when you check the mark scheme yourself, make sure you look at the different options that are available. So this one will be for 0.72%. Okay, so let's start off. I want the interest content of repayment. So the interest content is, we take the percent and times by the loan outstanding. So it's 5650 times 0.72%, so divide by 100, and that gives me £40.68. So I'll put that in this box here. Capital content of repayment, well, that is just your repayment minus your interest. So the repayment's 186.01 minus your interest, which gives you 14533. And the loan outstanding is the previous loan outstanding minus the capital content, because interest doesn't go towards it. So that's 550467. And then we start again. So it's £5504.67 times 0.72%, £39.63. 18601 is the payment minus the £39.63 to give 14638. And finally, loan £5504.67 minus the £146.38 to get 5358.29. And we're done there. Very high application maths 2024 question 5. EWA deposited £4,500 in available savings account on the 1st of January 21. Effective rates are followed. So we've got January 21 to March 21, end of March, 0.415% per month. And then April 21 to December 21 is 4.7 per year. And then from January onwards, 22 is 2.6%. So I'm going to do a little timeline to see what she's got. Now let's just check she's not putting more money in. She deposits £4,500 EWA. So if I deposit £4,500 on the 1st of January, so let's have a look. 1st of January 21, we've got 4,500, and that's only going to take us up to the 31st of March, but I'll just make that the 1st of the month to make it easy to see. And then we've got what the percent is, which is 0.415, so I'll put a 1 and divide by 100, 0.0415. And it's a power row because it's January, February, March, 3. Not out of 12 because it's per month. So I'll move on to the next one. From the 1st of April, I need to go up to the 1st of January 22, 31st of December, 1st of January, and that is 1.047, 4.7%. And the power this time is, well, that's 9 months. April, May, June, July, August, September, October, November, December. 9 months, but that's per year, so 9 out of 12. I then need to go from there, and it's just in the third place now, 1st of January to the 1st of January 24. So that is 1.026, and that's 2 years exactly. So since it's 2 years exactly, it's the power of 2. So there we are. We managed to fill in our timeline. So then we just do our sum. 4,500 times 1.00415 cubed times 1.047 to the 9/12 times 1.026 squared. 4,500 times 1.00415 to the power of 3 times 1.047 to the power of 9/12 times 1.026 squared. And you get 4
4964.357. So 2 decimal places, 4964.36. Part B, on the 1st of January 22, Billy opened an account with the same effective interest rates, and his savings goal was £6,000 by the 1st of January. So he's going between the 1st of January 22 and 24. So from January 22, it's 2.6%. 2.6% per year. Calculate minimum deposit he needs on the 1st of January to make his savings goal. So it's present value calculation. We're working backwards. So we're starting with 6,000, and we're not timesing, we're dividing. And it's 1.026. January to January, 2 years squared. 6,000 divided by 1.026 squared is 5699.759. So we're going to have to put in 5699.76. You can double check that. 5699.76 times 1.026 squared. It's just over 6,000, so we're done there.
Next we have Application of Maths 2023 question 7. Taylor opens a savings account the 1st of April 21 with a deposit of 400, and then the effective interest rates as follows. She makes further deposits on the £200 on the 1st of August, £250 on the 1st of April, calculated balance on the 31st of July 2022. On the 1st of April 21, she's put in £400. And then that takes us up to the 1st of August 21. 1st of August 21, where she puts in another £200, and the interest rate between them is 1.2% per year. 1.012 to the power of, it's 4 months in between there, 4 twelfths. And then she goes up to April 2022, but the interest rate changes. So I need to go to the 1st of February 1st, 2022. And the interest rate between there is still 1.012. August to February is 6 twelfths. 6 months. And on the 1st of February, she doesn't do anything. We just now go straight to the 1st of April 22, where she puts in £250. Then the interest rate at that point is 0.11%. which is 1.0011. Use your calculator if you need to get that one. And the number of months between February and April is 2, so that's squared because it's just per month. We then go to the 31st of July, which is the same as the 1st of August. And that is also 1.0011. And the number of months between there is 4. So now we can just start working on this. 400 times 1.012 to the power of 4 twelfths. Then we add 200. Plus the 200 is 601.59. Okay, so then we've got 601.59 times 1.012 to the 6 twelfths. But then we've got times 1.0011 squared. And then we add 250 at the end. So all of that, 601.59 times 1.012 to the power of 6 twelfths times 1.001 squared plus 250 is 856.52. Okay, our next bullet point then, we start with 856.52 and we're now going times 1.0011 to the 4. 856.52 times 1.0011 to the power of 4 is 860.29 to 2 decimal places because it's money. 294 but 29. Okay, and we're done part A. Just note, there was 2 methods to this, and if you use the alternative method, which is in the mark scheme as well, for method 1, you will get 860.30. It's just to do with where the rounding takes place. You're rounding as you go with this, so your chances are going to be a little bit low, but that's fine. 860.30 with method 1, or using this method, which is what I prefer, 860.29. So part B says she makes a final deposit on the 1st of August of 2022, and on the 1st of December she's got £1,000. How much did she deposit? So this is a reverse one. Calculate the present value. So we're starting with 1,000. We're dividing by the interest rate, which is now 1.7% per year from the 1st of August. 1.017. August, September, October, November, then into December is 4 months out of 12. So that'll tell me how much is in our bank on the 1st of August. 1,000 divided by 1.017 to the power of 4 over 12 is 994.396, 994.40. So now to work out how much is in her account, well, what she deposited, that's what's in her account, but she already had 860.29, so we take them away. 994.40 minus 860.29 is £134.11. Now the mark scheme for this says 134.10, but that's using the answer from the other method of 860.30. Obviously we got 860.29, so it'll be a penny difference at 134.11, and that is completely fine. The Maths 2022 question 4. Zach puts £500 in the bank on the 1st of January 2018, 19 and 20. The effective rates are 3.3, 2.4 and 1% per annual or year, and he makes no withdrawals. Find the balance at the end of 2020. Two ways to do this. I'm going to do it by a timeline method. So we've got 2018, 500, 2019, 500, 2020, 500, and then we'll go to the end of the year, 2021, but nothing goes in. So our interest rates, we do 100 plus the interest divided by 100 to make it into a decimal multiplier. So that would give me 1.033. Use a calculator if you want. 1.024 and 1.01. So we'll start off with 500 times 1.033 and then add 500. So the first one is £1016.50, and then start again. 1016.50, 1.024 this time, plus the 500 at the end of that. And you get 1540.896 or 1540.90. And then we start again. 1540.90 times 1.01 is 1556.309, so 1556.31 to 2 decimal places. Just not on the mark scheme of this, the SQA designed it to be 1556.30 instead of 31, but we did say 31 would be an acceptable answer due to rounding, so I think the rounding's fine. Okay, on the 1st of January 2021, Zach deposits another 500 in his account. He makes no further deposits in his account. Calculate the annual effective interest rate needed for 2021 for the balance to be 2100. So we'll look at the present value here. We'll start with 2100 and we're dividing by how much is in his account. Well, he's got 1556.31 plus the extra 500. You can use a calculator if you want to get 2056.31. So if I divide them together, I'll get the decimal multiplier, which I then need to change to percent. So let me just divide them together first so you can see that. 2100 divided by 2056.31. That gives me that. So you now should be able to see quite clearly that at the end of that sum I have to take away 1 and then times 100 to change it to a percent. So I'll take away the 1 now, press equals, times 100, press equals, and we get 2.12, a bunch of other numbers, percent, and we're done there. We have, against the Maths 2022 question 6, the average price of petrol increased at the following annual effective rates: 2.1, 0.5 and 2.0 from 2018 to 2021. And we have to work out the average price, the overall percentage increase in the average price of petrol over these 3 years. Now don't be tempted to just add them up, that is not it. Imagine if I started with £100, I would do 100 times 1.021 times 1.005 times 1.02. I'd be times them by the decimal multipliers. So I need to times them together to get the overall percentage increase. So in other words, I do 1.021. I got that by doing 100 plus 2.1 divided by 100 times 1.005 times 1.02. Once I've done that, you'll see in a minute, we can do it in bits. 1.021 times 1.005 times 1.02. That gives you 1.046627. So with that answer, I'm going to have to take away the 1 and times 100 to find it back into a percent. So take away 1 times 100, 4.66, and a bunch of other numbers, 4.66%. Average price of petrol in 2021 was 136.4 pence per litre. Calculate the average cost of filling a 45 litre tank with petrol in 2018. So we're going from 21 back to 2018, but we already know that the percentage that increase was 4.66%. So all I need to do is divide by that to go backwards. So 136.4 divided by 1.0466. So getting my calculator back open for that. 466,271. That'll just divide by 1.0466,271. That gives me 130.323. So I then need to times that by 45 because it's 45 litres. So just times straight away by 45. That gives you 5864.55 and a bunch of numbers. But that's going to be pence. Now pence looks a bit nasty to me, so I'm going to divide by 100 to get £58 and 645, so 65 pence. 58.65. Due to rounding, you'll get 58.65 or 64.63, and that'll be completely fine.
SB Higher Applications of Maths 2023 questions 9. The Consumer Price Index, CPI in the UK, in April 2021 was 110.4 relative to a baseline of 100 in April 2015. Explain what this figure means in terms of relative purchasing power. So purchasing power is how much you can buy, basically, based with a set amount of money. 110.4 against 100 means that I can buy the same amount of goods in 2021 with £110.4 as I could with £100 in 2015. The minimum thing you can say to get a mark is purchasing power has decreased, but I would probably say, expand on that and say £110.40 can buy the same amount of goods and services in April 2021 as £100 could buy in April 2015. Simple as that. Right, the price of a new 3-door car rose in line with the CPI between April 2015 and April 2021. In 2021, the price of a new 3-door car was $14,108. Let me take a note of that. 14,108. Calculate the price of a new 3-door car in April 2015. So the consumer price index relative to 100 is 110.4. So I can do 110. I need to divide, because I'm going back to the original, by 110 over 100. So 110.4 divided by 100 is a decimal, 1.104. So I need to divide by 1.104 because it's went up by 1.104. So taking my calculator, I get 14,108 divided by 1.104 is 12,778.99. £12,778.99. Okay, the national living wage is the minimum hourly rate to be paid to an employee 23 years or older. In April 21, the national living wage was £8.91. This was raised to £9.50 in 2022. Given that a CPI in April 2022 is 119.0, determine if this rise is in line with inflation. So our new CPI is 119 relative to 100. So if we divide them together, that gives me 119 divided by 110.4, 1.0078, 1.0778. So the national living wage was £8.91 and it's been raised to £9.50. So you could compare the fractions, or you could just take £8.91 and calculate what it should be. So times 1.0778. So £8.91 times 1.07789, I think it was, is £9.60 roughly. £9.60 is what it should be. So the national living wage was increased below inflation. And we're done there. Okay, 7 continued. Part B, the consumer price index in April 22 was 119.0 and in April 23 was 128.3. Tom's gross monthly salary was 4,222 and in 23 it was 45. Determine whether Tom's monthly salary increased in line with the CPI. So how you do these is, there's a CPI and there's a CPI there for the two places. So if I do that divided by that, that tells me how much my salary should have multiplied by. So that's what I'm going to do. I'm going to do 128.3 divided by 119.0. That's what my salary should have multiplied by. And my salary was 4,200. So I'm going to times by 4,200. And that's what I should have in April 23. And that gives you a number of 4528.24. Now, his monthly salary is 4,500. So did it rise in line with the CPI? Not really. It did mostly, but not exactly. You could say yes, it did, but it was under by about £28 per month. Or you would say, what I would say is no, since 4528.24 is bigger than 4,500, or since his salary is less than 4528.24. And we're done there. We higher application maths 2024 question 7. You must refer to deductions from salaries given in the pre-release material. It says in 2023, Tom was paid a gross salary of £4,500 per month for 12 months from the 6th of April 2023. His annual income tax is £10,718.48, so we don't need to calculate the tax for a change. And he's opted out of paying pension, so we don't need to work out his pension. It says calculate Tom's net annual salary after all deductions, including national insurance. Here is the pre-release material for 2024, and it says deductions from salaries, tax bands, and national insurance, and then it finishes. So we don't need the tax bands because he's already calculated the tax. So the only thing we need is the national insurance contribution. So let's just copy that over. So I've copied that national insurance table over, and it says he earns £4,500 a month. And that is from the 6th of April 23. So if you look at this national insurance table, he's got a variable national insurance rate. First of all, it says you begin in £10.48 a month. For pay slips dated the 6th of April to the 5th of January, you pay this amount. And for the 6th of January to the 5th of April, you pay that amount. The thing that's changing is the percent, 12 and 10. I'm going to have to do two calculations. And then I'm going to have to work out his total salary for the year. So let's have a look. £4,500 a month from the 6th of April 23. So we're assuming he gets paid on the 6th of April, which is a bit weird date to be paid, but there you go. It's probably to make the sums easier. So let's call that 1 and call that 2. Looking at 1, from the months, he's got 4,500, so that's above this. So the first thing I do is do this number minus this number, 4189 minus 1048. I need to do 12% times 0.12 plus, and then he's got 4,500, and we need to take away the top bit of 4,189, and that's times 2%, 0.02. And that's going to be for how many months? Well, we've got April, May, June, July, August, September, October, November, December, and then January will be new, so that's 9 months. And then option 2 is the same sums, 4,189 minus 1048, but this time that takes 10%, so 0.1, plus 4,500 minus the 4,189, and this is still 2%. But now he's in the 6th of January, so January, February, March, and then April, we're past the 5th of April, so it's 3 months. Now that should add up to 12 months, 9, 10, 11, 12. So now we can work out his total national insurance. So we've got 4,189 minus 1048 times 0.12. So that's the first sum, 376.92 plus 4,500 minus 4,189 times 0.02, which is £6.22. So that total for that one is 376.92, which is 376.92 plus 6.22 is 383.14. And for the second one, we'll times at the end. We have got the first top bit, 4,189 minus 1048, and that's 10%, which is 314.10. And then we've got 4,500 minus 4,189 times 2%, so it's the same sum, but I'll do it just to be sure I didn't make a mistake. £6.22. So in total, we've got £6.22 plus 314.10 is 320.32. So now, in total, his total NI is 9 times 383.14 plus 3 times 320. Just check your sums. 383.14 times 9, 320 times 3 is 4409. So now with the calculator's net, remember, net annual salary. So his annual gross, we'll call it, is 4,500 times 12, because he has 4,500 a month, which is 54,000. So his net is 54,000 minus all his deductions. So that's 10,718.48 minus 4409. Any other deductions? We've got tax, national insurance, no pension. No, that's it. 54,000 minus 10718.48, minus again 4409 is 38872. And we're done there. SQA Higher Application of Maths 2023 question 4. It says you must refer to the information on tax bands 2022-23 given in the pre-release material when answering this question. Key points, so you need to go and check that booklet, so let's do it right now. So there's the tax bands there, copied in from the data booklet. Now it says James works in a large building company as a permanent employee and he has a gross annual salary of £36,700. James pays 4.7% of his salary into his pension, and then he pays 307,145 national insurance. So we don't need to work out his national insurance, which is given to us. Calculate his net annual salary. Net is after you take everything off. Now, we have to work out his tax. Remember, this is a one key thing. If you're working out someone's tax, you take the pension off first. If you don't do that, you're going to lose a mark. So taking off his pension, I need to take away 4.7%. Two ways to do that. Just work out 4.7% and then take it away. Or I'll always use multipliers when I get to higher. So I'm going to do, in my calculator, 100 minus 4.7, because I'm taking away 4.7. That's 95.3. So I'm going to times his salary by 0.953, and that will give me what his salary is after the pension's taken off. So I'm going to do 36,700 times 0.953. 0.953 times 36,700 is £34,975.10. 34,975.10 is his taxable. Right, now we need to use our table to work out the tax in each band. So we'll just do it line by line by line. So first line, we pay £0. Second line, well, his wages way above that. So I need to do for the second line, I'll just put a little dot, 14,732 minus 12,570, because that's the two bands, times the percent as a decimal, 19%, 19 divided by 100, 0.919. Now usually we just work these out separately instead of one big sum, so I'm going to do that one there. 14,732 minus 12,570, you can put brackets around that or just press equals, times 0.19, and you get 41078. So I'll just take a note of that, 41078, and then we'll do our next one. So our next one is this one. Let's call that I. For II, again, the highest there is 25,688, which is still below his salary. So I'll just do 25,688 minus 14,732 times 20% this time, so 0.2. So calculate again, taking my time, 25,688 minus 14,732 times 0.2 is 2191.2. So 2191.20. Okay, that's II done, II. That'll be this one. So in this case, I'm in the intermediate now. 43,662 is above his salary. So I'll do his salary minus the lower. So his salary is 34,975.10 minus 25,688 times the percent, which is 0.21 this time. So again, calculator, 34,975.10 minus 25,688 times 0.21 is equal to 1950.29. So his total tax, I just add up all the tax that I just worked out. $410.78 plus 2191.20 plus 1950.29 is 4552.27. So now his net pay, I just take his total pay and take away everything. Well, I don't need to start with his total pay actually, because I've already taken away the pension, which is down here. So we can start off with the taxable bit and just take away the national insurance and the tax. So his net pay is 34975.10 minus his tax, which is 4552.27, minus his pension, which is 307,145. So getting the calculator and being careful to put everything in right. 34975.10 minus 4552.27 minus 3071.45 equals 27351.38. So pound sign 27351.38. Okay, let's briefly go over where you're getting the marks for this. Let me just check this. So you're getting a mark for obviously your final answer, that is clear, but taxable income, if you get 34,975.10, if you take away a pension, you get a mark there. So let's just take a note of that here. There's a mark there. And then you get calculate the tax for starter, basic and intermediate band. So basically calculating all these taxes, you get a mark. You get a mark for calculate tax for the remaining bands and total tax to pay. So, starter, you actually get a mark for doing 0, then these two, and then a mark for the final band and the total. So you get a mark there, and then a mark obviously for your final answer, and them all up. SQA High Application Maths 2022 Question 8. You must refer to deductions from salaries and employee release material. So I'm going to copy that in a minute. But it says Sophie starts a job selling mobile phones. Her company provides the following benefits at the end of each month. So she's got a £1,000 salary, £20 for each mobile sold. And then a pension scheme. She pays 2.5% in and the company pay 6.5%. Sophie expects to sell 150 phones per month. Calculate the income tax she pays each year. So let's work out our salary first per month. 150 phones, so that's 20 times 150. Which is 3,000. So that means she earns 4,000 per month. Times that by 12. That's 48,000. Now, we do not work out our tax on 48,000 though, because it says she gets pension of 2.5% before tax in our pension fund. Don't worry about the company's one. They just put that money in, that's for a later question. It's a 2.5% I need to take off to work out her tax. So 2.5% of 48,000. That's 1,200, so taxable income 48,000 minus 1,200. 46,800 is what we're going to use. So now we need to find the tax bands. Well, I've already copied these in, but let me just bring it up. So there's your standard tax table. We don't need the national insurance, just the tax. So basically remember how this works is, first of all, 0 for 0%, and then we take away each band and times by the percent. And we can just put the answers next to it. So I'm just going to do that with my calculator. So I've got 14667 minus 12,570 press equals times 0.19. So the first number is 39843. So I just write 39843. Okay, the next one, 25,296 minus 14,667 times 0.2, because it's 20%, 212580. 2125.80. The next one, we'll just check our income, 46. So yep, we're still going. 43,662 minus 25,296 times 0.21. 385686. 385686. And then the last one is where we're in her income, so 46,800 minus 43,662 times 0.41, 128658. 1286.58. So her tax equals the total of all the numbers. Make sure you don't make a mistake typing them in. I get 7,667.67 pound sign. Now, if it asked us for our net pay at this point, we would work out our income tax. Let's hope we don't need to do that. And take away the pension, income tax and tax from her normal £48,000. Okay, let's move on to part B. Sophie's pension fund earns an annual effective interest rate of 10%. Calculate the expected value of Sophie's pension fund after the third contribution is made. So let's look at her pension benefits again. She earns £4,000 a month and she gets 2.5% in, and the company pays 6.5. So 6.5, 7.5, 8.5, 9% of her salary is pension. So we need to work out what our pension contribution is first. So pension per month, which is worked out as 9% of her salary, which is £4,000. That's how much she gets. So 9%, 0.09 times 4,000 is £360. So that's how much she's putting in each month. So it's just a little timeline. We've got month 1, we've got month 2, we've got month 3. She puts 360 in. We've got an interest, then we've got 360 in. We've got an interest, then we've got 360 in. And what is the interest? Well, it's 10% per year, so I need to change that to a monthly interest. So it's 1.1 to the power of 112, because it's only every month. So that's what we're timesing by, 1.1 to the power over 12. And if we're timesing the last one, well, immediately after the third is made, so no, that's when we stop. So continuing this question, we're starting with 360. We're timesing by 1.1 to the power of 12, and then we add 360 at the end of that. So that gives us 72287 to start with. So then we take our 72287 and we times by 1.1 to the 12. And well, that's 1 360, 2 360, so an extra 360 on that as well. And that's the third 360. And you get 108863. Sophie has a choice to leave the company pension scheme. State a reason why she would not leave the pension scheme. Well, she might not leave because she wants to save for retirement. It's important to save money for retirement. Or the main one, just due to the actual question, is that the company pay in 6.5%. So if she leaves, she will not benefit from the company paying 6.5% to pension. She's effectively losing that amount of money. So either that, or it is important to save for retirement, to save for future. Next we have Application of Maths 2024 question 9. You must fit the spreadsheet Esme's mortgage. Complete parts A and C and then complete it in the letterbox provided. Okay, Esme is building an extension to her house. She's been offered a £25,000 mortgage with an effective annual rate of interest of 3.5% over 5 years. Open the mortgage worksheet, complete the mortgage schedule to determine the level of monthly repayment amount and final repayment amount. Okay, so there's a spreadsheet, 25,000 annual, so we need to go monthly, so that equals 1 plus the annual to the power of 1 over 12, and then you need to take away 1. So you get 0.29%. Level monthly repayment, no idea. This is a goal seek question, so let's just make it up, £300. And let's start filling in our schedule. So that equals this one, but that's outside the table, so you need dollars. Interest content of repayment equals round, because we're going to do it to 2 decimal places, and it's monthly effective rate times the mortgage outstanding, 2 decimal places, but we want dollars on anything outside the box. So $C, $9, that's looking good. Capital content of repayment, well that's just repayment minus interest. They're in the boxes, so no dollars.
and mortgage outstanding just equals mortgage outstanding minus capital. And how many payments? 60. So now we can just copy that down for 60 months. And we want to do a goal seek. So we want to make this 0. So we're going data, what if analysis, goal seek. We want to change that to 0 by changing cell, well, the level monthly payment, of course. So OK, that'll run its little thing, press OK. But as per usual, although it says 415.18, that's actually been rounded or truncated. So I would round that or take away the 9. It's up to you. You can go up to 8 or down to 7. It makes no difference. I'm just going to make it 8. So there's my actual repayment. It'll adjust itself, and that means my final payment's off by this much. So that means I need to take away 0.06 from 415.18. So minus 0.06. And then we get back to 0. Is what we need. So 45412 is our final repayment. Either type it in or reference the cell. Okay, back to here. Esme's new building insurance once the extension is complete. She's choosing between 2 options. This one, cost per year is £216.94 for £350 excess, or £285 to £195 for £100 excess. Stated one advantage of having a high excess amount on your insurance policy. Well, even just if you didn't know, if you look at it, a higher excess is giving you a smaller cost per year. So that's all you need to type. Higher X, I'll just get rid of that. Excess gives a smaller cost per year. So that's 1. That's an advantage. Part 2, one of the windows in Esme's house is broken. She says whether to make a claim. Explain why Esme may choose not to make a claim using her insurance policy. There's lots of reasons for that. It might mean that her premiums go up in later years because she's made a claim, or it might be because the excess is too high and it's cheaper just to fix a window without making a claim. It could make her premiums more expensive in later years if she claims. It could be a reasonable option, or maybe you would say that it may be cheaper to replace the windows herself rather than paying the excess. Could be something like that as well. Okay, the maximum monthly repayment amount allowed by the lender is £550. Esme chooses to reduce the term of the mortgage by increasing her maximum monthly payments to the maximum amount. Open the increased worksheet. Complete the increased payment schedule for reduced term and calculate the final repayment amount. Determine how much money this would save Esme over the term of her mortgage. So there's the increased payments amount. 25,000, 3.5% annual. So we can work out the monthly as usual. 1 plus this power 1 over 12 minus 1 is our monthly interest. So how long is this for again? No, we don't know. Interesting. So we're actually going to have to guess or work out how long it takes her and do a monthly payment. So we're just going to copy down until we get 0. That's interesting. So the repayment is always going to equal this, and that's dollared. We're not goal seeking this. This is a repayment. Interest content of repayment, as per usual, equals round. And we're going to do this times the monthly effective interest to 2 decimal places, and make sure you put dollars on anything outside the table. Capital content, that equals the repayment minus the interest, and mortgage outstanding equals the mortgage minus the capital. So now all we're going to do is copy that down and see what happens. We're not going to go above 60, of course, because we already know it takes 60 months on the previous one. You're going to have to keep doing it until... So you can actually see after that amount, we've went too far. because you're starting to get minuses. So we can just take them away, and that means that the repayment in month 49 is just 427.19, and you'll get your 0 there. So there you go, 427.19 is the final repayment amount. Determine how much money this will save Esme over the term of her loan. All we need to do is do a sum here. So let's do that at the side, equals sum all of these. So there's the sum for that one, and the mortgage before equals sum of all of them. So there's your two totals. So we could just do equals this box minus this box. It's not worked, has it? If it doesn't work for you, just check the number 2725074. 27250 minus, let's just click that box now. Right, we'll give it 42355. Could have also done this just by doing the difference in the interest, but there we are. And then the last bit of the question, print in mortgage worksheet in value and formula and increase in value and formula. I hope you know how to do this, but by now there's your value view, and you just go to formulas and show formulas and then print it in formula view. You just do that for both of them. Value view, formula view, and we're done there. SQA Higher Applications Maths 2023 question 11. This one's about Ramsey's loan, and we have to use the spreadsheet. So it says Ramsey applies to take out a loan of £6,000 with a term of 3 years from a bank. 11 monthly repayments are made at the end of each month. The effective annual interest rate is 6.3%. Open the bank loan worksheet and complete it to determine the level repayment amount and the final repayment amount, then determine the total interest paid over the term of the loan. Okay, so monthly effective interest rate equals 1 plus $C $7 to the power of, well, it's 1 over 12, and then we need to take away 1 again to get it back to the interest rate, so minus 1. And we get 0.510%. The loan pay was 3 years. The monthly repayment amount, well, we don't know that, so we're going to do a goal seek in a minute to find it out. So let's just pick a monthly repayment amount of, say, £200 for the sake of argument. Okay, so the repayment is equal to $C $10 equals $C $10. Interest content of repayment. So the interest content is equal to, we'll obviously have to do the monthly interest times the loan outstanding. So that equals the monthly interest, which is $C $8, times the loan outstanding, which is just this one here, F16. We want that to change over time, but we don't want that to be any more than 2 decimal places. So we're going to round that to 2 decimal places. So comma 2, press equals, and make sure we get 2 decimal places. Now we don't need to round the rest, because once I've rounded one of them, the rest will be 2 decimal places anyway. So the capital content of repayment is equal to the repayment minus the interest content. And then the loan outstanding is equal to the previous loan outstanding minus the capital content, how much you've paid off. So we can press equals there. So we've got our formulas filled in. And now we need to copy and paste all these down. So let's just highlight all these cells and go all the way down to 36 weeks. And you'll see that at the end, it's completely wrong because we just picked a random number. So we need a goal seek to change that cell. So we're going to highlight that cell and we're going to go to Data, Hot Enough Analysis, Insert, Goal Seek. We're going to set that value to 0 and we want to change our repayment amount, which is up here. So press OK. Eventually it'll do the sum for us. And you'll notice that at the end we get 0. And you would maybe think you're done there, except the fact that when you do a goal seek, it doesn't really care. It's not rounded that for you. And you only want it to be 2 decimal places. So we're going to have to adjust that to make it 2 decimal places So that gives me 182.87 in here. And then our final repayment amount will need to be adjusted as well, because we've got this extra 7 pence hanging about. We don't want that 7 pence. To deal with that, we just add the 7 pence onto 182.87. So for our final repayment amount, it equals $C $10 plus 7 pence, which is 182.94. So adjusting that final amount is 182.94. We can either reference it or just write 182.94. I'm going to reference it. C11 equals $C $11. And now we've got 0 here, which is excellent. And to get our total interest paid, that's just the sum of all our interest payments. So the sum of here all the way down to there. Close the brackets, press equals, and we get 583.39. Ramsey's application for this loan was rejected. State a reason why a bank might reject a loan application. So let's just put this answer in here. We might reject it, but the main reason is to do a credit check and they might have a poor credit rating. So I'm just going to write poor credit rating as my answer. Or you could mention the affordability of a loan. Okay, let's move to the next question. Ramsey decides to borrow money from a loan company. The company offers Ramsey £6,000 for 3 months with a fixed level monthly payment of £250. Complete the loan repayment schedule to find the annual effective rate of interest, determine the difference in the interest paid between the two loans. I'll be able to print it off. So there's our loan company spreadsheet. £6,000. We don't know the interest rates, but we do know it's 3 years and it's £250. And we have to work out the total interest paid and the difference in interest paid. So the repayment we can put in here is equal to $C $10. Now, annual effective interest rate, since we don't know it, we might as well just make it up. So I'm just going to say 10. And then the monthly interest rate is going to be the formula as normal, equals 1 plus $C $7 to the power of 1 over 12, take away 1. So there's our interest there. So the interest content of repayment, that equals, remember we need to round, and it's going to be $C $8, the monthly interest times the loan outstanding, which is this cell here. And we want to round that to 2 decimal places because it's money. We've rounded that one, so we don't need to round anything else. Capital content is just going to equal the repayment minus the interest. Press equals again. And the loan outstanding is just going to equal the loan outstanding it was minus the capital content. And we can press equals. And now we can copy that down to 36 months. And it fills it all in, but obviously it's all wrong. Because at the end, it shouldn't load anything. So we want to do a goal seek. So we go to data, what if analysis and goal seek. We want to set that to value 0, but this time we want to change the annual interest rate. So this value here. So press OK. After a little while, it will change the annual effective rate to 32.61%, and therefore it will change his monthly interest rate to 2.38%. Now his annual interest rate is not money, so we don't need to round that to 2 decimal places or anything else. We'll just leave it as it is. It's 32.61 in a bunch, and the monthly interest rate is going to be 2.38 in a bunch, but that's fine. We can just leave that as it is. To get the total interest paid, we just need to do a sum, remember, sum of all the interest. So starting here and going all the way down to the bottom. And that gives us £3,000 of interest is paid. Wow, that's an expensive loan. If it's in total interest, well, that's just going to equal this cell minus back to our bank loan. Total interest paid in this one was this one. Press equals, and that gives me 241661. And that's the answer to the question. So again, we're just printing this bank loan worksheet in value view and formula view. So just a reminder, you go File, Print. There's the page, but we want it on one sheet only. So we go to Fit Sheet on one page. Check if one looks better. I think that one looks better. And then we just print that. Now we want Formula View. So you go to Formula, you go to Show Formulas, and then you would go and print that again as well, so that you can see all the formulas that you've put in. And that's us done.
Next we have Accumulation Maths 2022 question 9. You must have fit a spreadsheet Q9 car repayments when answering this question. Okay. Maria is buying a car for £15,000. She's arranged a loan for the full amount from the bank to be paid back with level monthly repayments for 48 months. The annual effective interest rate is 9.5%, with the complete loan repayment schedule to determine the level repayment amount and final repayment amount. Okay, so here is the spreadsheet. We've got some boxes to fill in and then find a final repayment. So first of all, the monthly effective interest. To work out monthly, you start off with equals this cell plus 1 to the power of 112. And then we need to take away 1 at the end again. And you get 0.76%. Monthly repayment amount, well, we don't know it, so let's just make a number up, 300. Final repayment amount we'll come back to, so we now need to fill in our table. Okay, so our repayment, well, that equals our monthly repayment, but we need dollars around that because it's outside the table. So $C, $11. Our interest, well, that equals, we need to round because it's 2 decimal places for money. And it's going to be our monthly effective interest rate times the loan outstanding. Now, we want that to 2 decimal places, but don't forget anything outside the table should have dollars in it. So $C, $9. Make sure you double check. Inside the table, no dollars. Capital content of repayment. Well, that's just equal to your repayment minus your interest. So there we are there. And your loan outstanding, well, that equals the previous loan outstanding minus whatever the capital is that you paid. So we can just do that. We wouldn't need to round this one because these ones used the figures already, but we're rounded, so we're fine. And then we'll just extend our table down, 48 months. There you go, just make sure it stops at 48, if not drag up or down. And you'll notice that the final box is not 0 because we just made up 300. So we do a goal seek. We go what if analysis goal seek. We want to change that to 0 by changing the monthly repayment, that box there. So press equals or enter, and you'll notice it does it for you. It looks like it's done it well. However, look at our monthly repayment. It says 37406, but it's not rounded it, it's just displaying that. So we need to change that here. You can either change it to 37405 or 37406, it doesn't matter. Basically, we use the 06 because you can round up 8, so I'm just going to do the same. So there you go, 06. Now it will change everything except will be an extra or a little bit less here. So to adjust for that, click this box, check what that says, minus 0.07, so click minus 0.07. If it's a positive number here, put add instead, press enter, you'll notice that now jumps to 0 and you've got a final repayment amount of 373.99. So you can just put that in this box. And we're done there. Okay, the car dealership has their own finance options. Pay £300 a month for 48 months to return the car. Or additional charges will apply if mileage exceeds 24,000. Option 2, pay £300 a month for 48 months, keep the car with an additional payment of 5,000 in the final month. We'll have to open the car finance and complete the car finance repayment schedule to find the annual effective interest rate for option 2. So there's the car finance one there. So annual effective interest rate is what we're trying to find. We don't know it, so we're just going to guess. So 40. I don't know, pick anything you want. Just don't pick anything too small. Okay, again, monthly effective interest rate, so that equals 1 plus this to the power over 12, because it's a month, take away 1, and we get our monthly. Loan period is 48, monthly is this, additional is this. So our repayment equals $C, $11, which is 300 this time, and that's not a goal seek. Interest content of repayment, same as before, $C, $9, because that's the monthly, times the loan outstanding. And we've not rounded, of course, so we go back in our formula if you forget that and go round 2. And we get this number, 42654. So the capital equals the repayment minus the interest.
and the loan outstanding equals the loan outstanding minus the capital. Now notice with me, I've picked quite a high percentage here. Now you get some negatives. Do not worry your heads with this. Just go through it and do the goal seek and you'll be fine. So now I copy, drag and drop down for 48 months, but there's one thing I need to remember, that additional payment. So it's an additional payment of 5,000 in their final month. So I'll just quickly change that to say plus 5,000. You notice my goal seek again, I have to change this. So it's what if goal seek, change F63 to value 0. But this time we're not changing the repayment, we're changing the annual effective interest. After a little while we get 11.05%. Notice that says dash or 0. It depends on how the spreadsheet's set up, but that is definitely 0, so we're good. You might be wondering, well, on the previous spreadsheet, we went back up and we checked this cell and we go, oh, there's all these extra numbers. Do we do this for this? We do not do this for this. This is a percent. If we change that, that means we change her payments, but she's agreed to pay 300 and she's agreed to pay 5,300. That is her payment. So they'll quote to her 11.05%, but they'll do it as 11.04648, so it all works out on their end. Key point is, money you change where goal seek back to two decimal places. Other stuff, generally speaking, you just leave it as it is. So C, state 2 reasons why Maria might decide to purchase a car using the bank loan instead of car dealership finance options. So if we look at the finance options given to us, option 1 is pay 3,000 and return the car, or she might exceed the miles. So she might not want to do that because she has to return the car. Option 2, she has to pay an additional 5,000 in the final month, so it's not the same monthly payment each month, whereas the bank loan is. So that's all you have to write, really. So Maria will own the car outright after 48 months without needing to pay an additional £5,000, would be one good reason. If Maria does not want to keep the car, then it is risky, because if she does more than, she will have to pay a penalty. Let's just look at the interest rates. On the bank loan, it's 9.5%. On the car finance deal for keeping the car, it's 11.05%. So the bank loan's actually a lower interest rate. So you could say that as well. Bank loan has a lower interest rate. And there you go, we're done there. It now says value view and formula view, and then print your worksheet. So let's have a look at the worksheets. You've got bank loan, so you just got to file, print it in value view and formula view. To get it into formula view, you just go to formulas and show formulas, and you do the same for car finance. You print this as normal, and then formulas show formulas, and print your formulas, and we're done there.
SQA Higher Applications of Maths Specimen Paper 1, question 10. Let's have a look at the first question. This is Excel 1. You must have hit a spreadsheet, but Carol receives a gift of £2,500 and is considering what to do with it. She has a savings account that pays interest at an annual effective rate of 1.25%. Calculate how much interest Carol would earn if she invested this gift in her savings account for 34 months. So this is the first part of the question, which is not actually the Excel part. So we've just to work this out ourselves. So I need to do 2,500 times 1.0125. But then it's 34 months. So it's 34 months out of 12 months. So to the power of 34 out of 12, which is 2,589.56. But I need to read the question. It says how much interest. So I need to take away the original amount you had, which is 2,500, which will give you £89.56. Hopefully that's quite easy. And we can move straight on to the actual Excel part. So here's the Excel part. She has a personal loan. She borrowed £8,000 to be paid by level monthly payments for 48 months. The first repayment made one month after the loan. Interest is charged at 4.9%. Open the loan schedule, original loan, and complete the formula in the loan schedule to calculate the level monthly repayment amount and the final repayment amount. So this is your standard thing, so let's do part B. So first thing we need to do is the monthly effective interest rate, so that equals brackets 1 plus the percentage for annual to the power of 1 over 12, and then you need to take away 1, and you get 0.4%. So monthly repayment, well, we have to work that out. We don't know, so we're just going to guess it. So I'm just going to say 200 and have at it. And then we go into our table and try and work out our table. So month 0, nothing happens. This is usually filled out for you. And the loan outstanding was, again, it's usually filled out for you, but it's not for this question for some reason. So we'll just go and check it out on the question. £8,000. So that's what should be in here. And then we can start at month 1 and month 2. So repayment, well, that equals our guess, and we dollar that, so F4. Interest content of repayment next. So that equals our monthly interest, dollared. But let's actually round first, remember. Round our monthly interest dollared times the loan outstanding, which is not dollared, and then it's comma 2 because I want 2 decimal places. That's the one that you round. So there's our interest content of repayment. Capital is repayment minus interest. And loan outstanding is loan outstanding minus capital. So that's us done month 1. We can copy that down for month 2. And then we can just keep copying down for all the months we need. So how many months is it? Well, it's 4 years. So that's 4 times 12, which is 48 months. So down we go. And my guess has taken into the negatives, so it's too much. So we need to go seek it to see what happens. So press that, and you go to data, what if analysis, go seek. Set cell there to value 0 by changing cell. And it's going to be the one we guessed at the start, the monthly repayment. Let it run and do its thing. Eventually it'll get an answer, 183.49 it says, but remember that answer isn't actually 183.49. We have rounded that for you, so you need to adjust yourself. So the next step is 183.486. You can round it up if you want to 49, or you can leave it as 48. It's up to you. I'm going to round it up to 49. And then I need to adjust my final repayment manually. So going down the bottom, you can see here that it says minus 0.21. So I need to take this and go minus 0.21. And then I'll go 0 or dash. And that's me done there. So the final repayment is 183.28. I'll just write that in there. Final repayment, £183.28. And then let's go back to the question and see what it was asking us. We have a monthly repayment and final repayment amount. So I've done that. We got £183.28 for the final and 183.49 for the level monthly repayment. Next part of the question. Carol has just made her 14th repayment on the loan. She decides to find out the impact of using £2,500 gift as a lump sum to reduce the outstanding balance. The loan provider agrees to reallocate the new level monthly repayment amount to be paid over the remaining 34 months. Copy the loan worksheet and rename it Pay Lump Sum. Adjust it as required to calculate the new level monthly repayment. On the Pay Lump Sum worksheet, calculate how much Carol would save in interest payments by making this lump sum payment. And then state a reason for something which we'll get back to in a minute. So let's go ahead and look at our Excel. So let's copy this over. We're going to make a copy, it says. So this is called Pay Lump Sum. Now it's after the 14th payment. So I'm going to add 2,500 in this point. So now I'm going to have to go seek this. So I'm going to have to do a new monthly repayment for all of that. So let's take a new tab, call it New Repayment. And we need to reference it from this point. So let's just go seek this. So let's call it 200 for the sake of it. Let's make it money. So we're going to goal seek this one. And we'll just copy that down from there. You can just double click there if you want. And let's goal seek. What if analysis? Goal seek. We still want that to be 0 by changing our new repayment. So it does some work and we get £105 exactly. But it's not 105, is it? It's rounded it. 104.70, but 71 is what the SQA wanted, so we'll put 71 in. Format cells. Currency to 2 decimal places. And then final repayment. We're going to have to adjust our last one again. This should all be currency, so it's not been set up for us, so we just need to do it ourselves. Format cell. We'll just say currency 2 decimal places. If that happens, it happens. I mean, this is an old paper, so chances that it won't happen. Final repayment, so take away the 0.27, and we get 104.44. And there we are. So now we need to work out the total interest for both of these. So for interest for this one is equal to the sum of all the interest payments. £628.73. And then on the original one, we want the sum of all the interest payments. Which is £807.31. So our difference is, so it was £807.31 minus £628.73, 178.58 is the amount saved. And to answer the last question, state one reason why Carol may choose to pay the gift into her savings account rather than use it to reduce the balance of her thing. Well, it could be any reason. She might just want to save the money, have the money accessible. So just to write something to ensure that her money remains accessible would be a reasonable thing, and we're done there.
Higher applications of maths, additional specialism in paper B, question 11 on Karen's pension. So we're going to go for an Excel question today. And one thing to note straight away with this is the Excel actual marking scheme is wrong for this question. So bear that in mind when we go through it if you want to follow along. So it says, Karen decides to start saving regularly towards her retirement. She aims to retire from work on her 65th birthday. She wants to estimate how much she needs to save by age 65 to cover the cost of living in retirement. She expects these costs will be payable at the start of each month from her 65th birthday up to her 80th birthday. She estimates her cost to be £1,500 at age 65 and will increase every month with inflation at an effective rate of 2.5% per year. She also expects that she'll be able to earn an effective rate of interest of 4% per year on her savings during her retirement. So we have to open the pension fund worksheet and complete the relevant formula to show that she must save £243,960 by her 65th birthday to cover the expected cost of living in retirement. So here is a copy of the spreadsheet. You'll notice I've already put the inflation rate in here and the interest rate in here. So first thing we need to do is work out, well, time from age 65 to 80 in months. So we could work that out ourselves or use a calculator. So 15 years times 12 is 180. So we can type in there 180 because that's how many months. Now the inflation rate per month, well, that is equal to inflation rate per year. So $C $4, and it's 1 plus that number because we need to do 1.0. So in brackets 1 plus $C $4, and we need a power. So per month, power 1 over 12. And then at the end, we need to take away the 1 again to get it back to 2%, so minus 1. And we get an answer of 0.206. $C $5. We're going to reference that cell. So it's 1 plus $C $5 to turn it into 1.04 to the power of a 12, because it's 12 months in a year, and then take away 1 at the end. And we get 0.327%. So time in age after months. So we've got up to 180 of these to do. So 0, 1, 2, we can highlight that and we can just drag down till we get to 180. Just keep going all the way down. That box in the right hand corner. Five to go. 1, 2, 3, 4, 5. And we get to 180 months. So we've extended that table back to the top. So in the cost of living box, we're going to say that that equals around $C, $3. And we're going to times that by, so times, open brackets, and it goes up by inflation per month. So 1 plus $F, $4. It goes up by that per month. So to the power of, now we want the month to change every time. So we've already got a cell for months, it's B10, 11, 12. So to the power of B10. And that means that for month 0, it'll be 1500, month 1 to the power 1, month 2 to the power 2, and so on. And then we want to tell it, we want 2 decimal places, so comma 2. And we can press equals, and we get an answer of 1500. Present value at age 65, that equals C10, but present value is divided instead of times, so divided by 1 plus, and we want the percent, well, interest rate per month. How much does our money went up per month? So 1 plus $C, $F, $5, and then to the power of the months, which is B10. Press equals. Okay, so we can now copy and paste these down. So we can just highlight them. And we can go to a box or right track and copy, but I'll just go to a box and pull it down, because I know that's what you'd probably do. 180, and it fills it in for us. So how much does she require? Well, that equals the sum of this one all the way down, and we can drag down or use the formula, type it in, but I'll just drag for you so you can see, to this one, close my bracket, press equals, and we get an answer of 243,959.32. Going back to the question, she must save approximately 243,960. 243,959.32 is approximately 243,960, so we have completed that. Okay, Karen just celebrated her 20th birthday and her monthly salary is 2,600, which is constant and paid to at the start of each month. She plans to make regular level contributions to her savings directly from her salary in order to meet expected cost of living and retirement. She decides to make these contributions immediately when her salary is received every month between now and age 65. Karen expects to earn an effective rate of interest of 5% per year on her savings before retirement. Use the savings account worksheet to calculate what proportion of her salary she must save each month to make her expected cost of living in retirement. So let's go back to the spreadsheet. So savings account is this one. So we've got some boxes filled in already. Time until retirement in months. So she's just completed her 20th birthday and it's up to 65. So that's 45 years times 12 months, which is 540. So we can type in 540 in here. Interest rate per month, well, that equals the interest rate per year. So $C, $4. And remember, it's 1 plus that. 1 plus $C, $4 to the power of 1 over 12 minus 1. And we get an answer of 0.47%. Savings required at age 65, well, we know what that already equals. We can either type it in or just go back to here and press that and press equals, and it will automatically copy it over for us. So we're trying to work out how much she needs to save to make this number. So we're going to have to use a goal seek for this. So I'm going to put a random number in here. Let's say 200 to start with. We don't know, but we'll just say 200. We'll work out the contributions later. So let's put our months in. We've got time after age 0, 20 months, 0, 1, 2. We're going to copy that down. It's 540, which is huge. But let's just go. Almost there. And we're going to stop not at 540, but at 539. And that will give us 540 months. Okay, so we've copied that in. Contributions to savings, that never changes. So we're going to just say that references $C $5, and it always references that. So we'll just keep that and copy that all the way down. All the way down to 539, and that will just fill in for us. Back up to the top. Accumulation at age 65 of contribution. So this is a funny calculation. This is going to be equal to, well, C10. We're going to round it, obviously. So we'll round it C10 times 1 plus the percentage rate per month. So $F$4. And it's the power of it is funny. So to get the power is very difficult. You need to really think about this one. Imagine she's 20-year-old. She's now got the whole 540 months to go. After 20-year-old in 1 month, she's got 539 months to go. And at 2 months, 538. And 3 months, 537. So I need to find a way to write that. Well, I know I'm starting with 540. I'm just taking away the number of months. So that equals the time until retirement, which is 540, minus the number of months, which in this case is B10. And then I want that rounded to 2 decimal places. Close the bracket, press equals, and you'll get an answer. And we then just copy and paste all that down, so that will just change every month. So she'll get less and less each month, which makes sense, right? Because if she puts money in the bank a month before retirement, she's not going to get much interest on it. She's going to get a month's worth. So copying it all the way down to 539, we get it filled in. And then to work out how much total accumulation of contributions to savings, that equals the sum of, and we're starting at this cell and we're going all the way down to 539. That'll give us 540 months. Close the brackets, press equals. Lo and behold, it's not equal to the savings required at age 65. It's too much. So to fix that, we need to do a goal seek. So let's just click this and go data. What if analysis goal seek? And we're going to set that cell to, we're just going to type in 243959.32. And what cell do we want to change? We want to change our contributions to savings, so this cell. And press equals or OK, and we're done. It will quickly do the goal seek for you, and you'll notice that it changes it to 123.97. It's been rounded. So contributions to savings as percentage of salary. So that equals her contributions to savings, $C $5, divided by her salary, $C $3. And if we're lucky, this has already been set up to be a percentage. If not, we can change it in a minute. But we get 4.77%. But not on goal seek here. So usually when we do the goal seek, we then change this final value to 2 decimal places because it's actually more than 2 decimal places, it's just not showing you it. You can see that if you just do this, it's not been rounded at all. But if we were to change that to 2 decimal places, it would change all of these to 2 decimal places, which it isn't at the moment. It's just not been rounded, it's just not showing it. And therefore, this number here would change. Now, that might confuse you, but it wouldn't actually be wrong for this question because it would change it in such a way that it would still be approximately 243960, which is what the original question said. The SQA are not clear on whether you should round this or not, but just bear in mind, usually you do change this value, but in this case you would not change any final value because it's meant to be month level payments. So it would still be 123,970 for every single month because there's no adjustment to a final payment. So let's just show you that here. Let me change this to 12397 and you'll see what I mean. We get 123.97. If I press equals now, look at this box here and this will change. It's changed from that to this, but that's still 243960 approximately, so that's fine. So if you did want to do that and do what you do in every single question like this, then do that. But it wouldn't actually make a difference for this question, and the SQA marking scheme is not clear whether you should or not. But I think technically speaking, after a little bit of reflection, you really should be having 2 decimal places. It also doesn't change the answer here. If I put my contributions to savings equals will be $C $5 divided by $C $3, you can still see it's 4.77%, so it makes no difference at all. But just something to bear in mind when you're looking at this question. It looks like the SQA, I've not really thought about it as deeply as I should have done, but it is a specimen paper after all. And that's us done part B. Part C says, describe 2 risks which could result in Karen not having enough savings to cover her costs of retirement. So you can say anything reasonable here, but a simple risk would be, what if she lives beyond 80? She's not got enough money. So we could just say she lives beyond 80 years. And risk 2, so those things she could say. She could say she could lose her job. She could say her interest isn't as expected. Anything that seems reasonable. I'm just going to say Karen may lose her job and not save as much as expected. And that would be a reasonable one for that mark. Right, let's go and check the marking scheme to see the differences in these formulas. So, first one was pension fund. If we go to the mark scheme, it says 0.205% and 0.327%, and that's right, that agrees with what we got. Obviously, we've got 206. But don't worry about that. If we check the cell, and we go to home, you can see that it's actually 205 and so on. So same with this one. If you just go to home and check, you can see that there is more. Next thing, cells C10 to B190. It mentions A11. There's nothing in A11. It's nonsense. It's B11. So that is a complete and utter mistake on the SQA's part. Everything else I think is fine as long as you got that and you get your money, but you need to watch out with it. This doesn't agree with the question because the question is approximately, it says 60. So as long as you got 243,959.37, don't lose your head that it's not 60. It says approximately. Okay, part B. This is where I think the SQA made a big mistake. If we go to part B, we get all this filled in, and then it tells you to calculate the sum of the monthly contributions. It tells you to route the sum C10 to C550, and it's D as well, not C. You see? If you add up the contributions to savings, that doesn't tell you the accumulation. So we actually have made a complete mistake on this sum in DD. So just watch out for that. And then obviously if you did it the way I did it correctly, you will get 12397 and 4.77%. But if you try and follow the SQA, it won't actually work out correctly. Okay, hopefully you found that useful. A little bit of work on Excel, looking at the SQA Higher Applications in Maths question paper. That was the specimen paper B, question 11 on Karen's savings account. Take care, stay safe, and goodbye. Higher Applications in Maths 2024, question 3. A ship is being repaired, the propeller must be removed. For repair to be carried out, the table shows a list of tasks required to complete this job in the time required, and the order where it must be completed. So we need to complete a Pert chart showing the earliest start time and latest completion for each task. So let's start off A, disconnect electric. So A is this one, and that takes 2. Now I'm going to warn you here, this is a tricky Pert chart question. There's something weird about it, and I noticed it after I'd done it already. So I'm going to show you this. B, C, and D come after A. Just make sure it says after A. So that's B, C, and D. But that's not the order to write it in, because E comes after D. And it only goes after D, not after B, C, and D. So what you have to do actually is put your D in this box here. So let me just switch that around. I thought a lot of you did that. So you've got B, D, C like that. So now you can then fill it in. So B is 12. D is 8. And C is 24. Just double check that because you put a different order. B is 12. Yep. D is 8. Yep. And C is 24. Yep. So now we continue. After D is E, which is 4. So there's E there. And that takes 4. After B, C, and E, we've got F. B, C, and E, F. And the next two are the same, so that can be G and H. And that's 14, 12, and 8. And then after F, G, and H, we get I, which is 6. And after I, we get J, which is 8. Okay, so then we can do a forward scan. So we've got 0, 0 and 2 makes 2, 2, 2. The only one that for E before it is D. So it's 2 and 8 make 10 because E doesn't rely on B or C. And then F, G, and H are after B, C, and E. So we've got 2 and 12 is 14, 10 and 4 is 14, 24 and 2 is 26. So that is 26. 26 and 14 or 12 or 8, well 14 is the longest, so that's 26 and 14 is 40, 40 and 6 is 46, and 46 and 8 is 54. And now we do our backward scan. 54 take away 8 is 44, 46. 46 take away 6 is 40. But then again, be careful, this is a funky one. F, G, and H lead to BCE. That's fine, yeah. So we've got 40 minus 14, 40 minus 12, 40 minus 8, and we take the 1, which is the smallest. So 40 minus 14, which is 26. So that's 26 in here, here, and here. And then for E, 26 minus 4 is 22 for D. And then B, D, C go back to A, so we take the smallest, 26 minus 12, 22 minus 8, or 26 minus 24. Well, 26 minus 24 is the smallest, so that's 2. And there's our completed Pert chart. Construct a Gant chart without float times for this job. Okay, so you can go up or down the way. I'm just going to go up the way. So I'm going to start with A, skip to B, then C, then D, then E, then F, then G, then H, then I, then J. So notice that these goes up in 2, so watch out for that one. And the first one starts at 0 and takes 2. Then B starts at 2 and takes 12. Start when it finishes, and it takes 12, so that's 2, 4, 6, 8, 10, 12, and it ends at 14. D starts at 2 and takes 8. So that is 2, 4, 6, 8. So that's D. And C starts at 2 and takes 24. And that one's not got any float time, so I can just make sure I line it up to 26. Okay, E starts at 10 and takes 4. So line that up, 2, 4, 6, 8. After 10, 2, 4, and there's my E. F starts at 26 and takes 14. So that's been lined it up, 26 and 14 make 40. Let's go along to where 40 would be. Quite happy with that. Yep. Okay. 2, 4, 6, 8, 10, 12, 14. G starts at 26 and takes 12. Starts in the same place. Takes 2 less. And F starts at 26 and takes 8. No, H starts at 26 and takes 8. Starts in the same place. 2, 4, 6, 8. And our last one, last two, I starts at 40 and takes 6. That should be it, but let's just double check. Yep, after 40 and takes 2, 4, 6. And then we've got J, 46 and 8. And there you are. Determine the critical path in the minimum time to complete the job. Or you can use your Pert chart, the Gant chart for this. You've got A to start with. Then after A, then it's C. Then straight after C, you're going to jump up here and it's going to go this one, which is F, then I, then J. F, I, and J. A, C, F, I, J. Now look at your chart up here to see if that makes sense. You've got A, no float time. C, no float time. That's got float time, so we skip it. F, no float time. I, no float time, and J, no float time. So you could have done it that way. Last bit of the question says, during the job of difficulties disconnecting the propeller shaft coupling, task H, determine the maximum time it can be taken to disconnect the propeller shaft without delaying the total completion time of the job. So we're looking at task H. Again, we can look in either chart. Task H is here, and I need to do I when F is finished. So I'm looking at that float time of 1, 2, 3, 3 boxes, but that's 2, 4, 6. So that's 6 hours. And we're done there. Basically, higher application of maths 2023 question 2. In a coupling competition, a contestant has 80 minutes to make a creme brulee. There's several tasks to complete. The contestants' timings are shown for each task below, and we have to complete a Pert chart as shown below. So let's go to the Pert chart, and then I'll open up all the tasks at the side so we can see exactly what's happening. So there's all the tasks. I'll just zoom into them. And we have got to make 3 scans of this. We need to do our standard, then a forward and backward scan. Okay, so let's start off with middle boxes. First thing we need to do is heat the oven. That's A. So let's write down A, maybe in here, and that takes 8 minutes. And then at the same time as that's happening, we need to gather ingredients and prepare the bowls. That's B. And that takes 10 minutes. Okay, so we've done these. I'll just make a little note for myself. Now we need to move down. C comes after B. So maybe C in here, and that takes 5 minutes. Also coming after B is D, and that takes 4 minutes. So they're happening simultaneously. After C and D, it says, is E, which takes 2 minutes. So there's E and 2. After E, it says F, and F takes 4 minutes. And now we need to get our next ones right, so let's just move that over. So after A and F, we've got G, and that takes 35 minutes. After F, we've got H, so just after F, that goes down the way to H. So that takes 12 minutes. And then after G, we've got I, which takes 3 minutes, and J, which takes 5. So we've done our forward scan. We can kind of get rid of this document now. We don't really need it. So let's do our forward scan. We've got 0 to start with here. And then moving on to the B, that also starts at time 0. And then 0 plus 10 is 10. So we've got 10 is when this starts. This one also starts at 10. And then looking at this next one is the key one. That is 15 because I need to wait until this one finishes. So 10 plus 5 is 15. And 15 plus 2 is 17. 17 plus 4 is 21. So this will both be 21. 21 and 35 is 56. So that'll be in I's. 56 and 3 is 59. So that'll be in J's. And down below, you've got 21 and 12. We've already done that one, so we've done the forward scan. So let's now do the backward scan. So starting off at the end, 59 and 5 makes 64. So I can put 64 here. Now going back away, we've got 59 because 56 and 3. Then we've got 56 because 35 and 21 is 56. And on this one, we've got 21 and 12, which you might think makes 56, but this is the key one, H. Because H is at the end, and then I need to wait till J, then that's actually really 64. So that's a key one there. You need to get that one. All right, let's move back to F. F is 21, 17 and 4. E is 17. And then we've got C and D. Again, they're going to be not just 10 and 15 and 14. C is 15. D has to wait, so that's also 15. And then back to B, we've got 10. A is a key one as well. A is having to wait until we get to here, so that's 21. In other words, it's the same as F, so it has to wait until F finishes. So there's a completed chart there. Let's see where we're getting the marks for that. So 6 marks this was worth. We get the first 6 tasks in the correct sequence. We then get a mark for the remaining 4 tasks and durations in the correct sequence. So basically getting your tasks in the correct order with the middle boxes gets you 2 marks. And then your forward scan from A to F being correct, so up to here, if all of that's correct, you get a mark. You then from G to J, if that's correct, you get a mark. And then backward scan J, I, H, and G. So you need to get all of them to get a mark. And then finally, to get the rest of them, you get another mark. So there's ways to make a wee mistake and still get your marks, okay? Right, let's answer the next part of the question. Part B says, when the contestant puts the balls in the oven, they realise the oven has not been heated to determine whether they can finish on time. So remember what these tasks were. Task A was to heat the oven, right? So that's not happened. They've went straight to task B and they've not heated the oven and they've got 80 minutes to complete the task. So we can say that since it actually takes 64 minutes, there are 16 minutes spare. So I can write 16 minutes spare. I worked that out by doing 80 minus 64. And then we can say it takes 8 minutes to complete task A. So can they still finish on time? Yes, since A is less than 16 minutes. So for marks for that one, you're getting a mark for either saying it's 8 minutes to complete task A over 16 minutes spare, and then a mark for saying yes because 8 is less than 16 or 16 is greater than 8. Okay, done there. SQA Higher Application of Maths 2023 question 6. The Gant chart below shows the activities used to complete a project. A is dependent on F and H. F is dependent on B, C, and E. E is dependent on D. And activities C and B are dependent on A. What does that mean? Well, that means that if you look at A, you need to do A first before you go on to B and C. If you look at E, you need to do D first before you go on to E. If you look at F, you need to do B, C, and E first. B, C, and E before you go to F. And if you look at G, you have to do F and H first before you move on to G, which is what a Gantt chart usually shows. So, state the critical path. If we look at here, I can't move on until after D. I need to wait until A. So I need to do A first. So A is our first thing. After A, E's already started, so it's not that. I'm now moving on to the next activity that I can do, which is either B or C. But B only lasts 2, C lasts a lot longer, so it's C. Now after C, I'm at here, moving up my Gantt chart. I can see I've got 2 activities that I could choose from, but that stops before this one ends. So I need to finish this one first before I move on, so that's F. And then clearly after F, there's only one activity left, which is G. So the answer is A, C, F and G. Part B, state the duration of the float time for activity B. So let's look at activity B. B and C are happening simultaneously. So there's 2 hours done. So I've got 1, 2, 3 hours left over before C finishes. So the float time is 3, not hours, sorry, days. Because the units are days. Make sure you put your correct units in. And then the last question, just talking about what a Gantt chart is and its advantages. State an advantage of a Gantt chart. Well, a simple reason which is worth the marks is that it's clear and simple to read. So you can just write it's clear and simple to read. Other options, looking at the mark scheme, any other reasonable explanation. So another one that you could have been taught is that it's easy to see the float times, because it is easy to see the float times from the bars. If we have Application Maths 2022 question 2, company provides a team of roofers to re-roof a house, and we've got this table and we have to complete a Pert chart. So let's jump into the Pert chart. We fill in the middle numbers first and the tasks. So the first task is A, and that lasts for 3. Second task is B for 7. The third task is C for 4. And then it goes D and E for 1 and 2. So D, 1, E, 2. Then it goes F and G for 1 and 4. F, G, 1, 4. And then it goes H for 6. And then we've got I and J. And they take 3 and 2. So there's my completed Pert chart. Going forwards, we do a forward scan. So how do we do a forward scan? We start with 0. 0 plus 3 is 3. 3 plus 7 is 10. 10 plus 4 is 14, so they're both 14. 14 and 1 is 15. 14 and 2 is 16. And now we've got a choice. 15 and 1 is 16. 16 and 4 is 20. We take the longest one because we need to wait. So it's 20 for here. 20 plus 6 is 26. And that's us done our forward scan. So we now do a backward scan. So we've got 26 plus 3 is 29. And 26 plus 2 is 28. But 29 because we're at the end. So it's still both just 29. And then to go backwards, 29 minus 3 is 26. 29 minus 2 is 27. So we pick the one which is the smallest, which is 26. If you've got a choice, pick the smallest one. 26 minus 6 is 20 for both of these. 20 minus 1 is 19, but 20 minus 4 is 16. 16 minus 2 is 14. 19 minus 1 is 18, so I pick 14. 14 minus 4 is 10. 10 minus 7 is 3. I completed Pert chart for 6 whole marks. The roofing company works 9 hours each day on this job. State the minimum number of days to complete the job. Well, how do I know how long it took them? The last number, 29 hours. So it took them 29 hours. Divided by 9. You can use a calculator to see how many that goes in, but you'll see that it's 3.222. You can't have part of a day. You do day 1, day 2, day 3. We'll complete it on day 4. So 4 days. And we're done there. Construct a Gantt chart without float times for this job. Well, the float time is when, if you look at like a task like D, it starts on day 14. It is expected to last a day, but you can actually take your time and end at the end of day 19 if you want. So it's got float time in it of 4 hours. So what is float time? Well, this one starts on hour 14. It can only take an hour, but you could take longer if you need to because you've got all the way up to hour 19.
But for the purposes of a Gantt chart, for a float time, you'll just do start at 14 and do a box for 1 hour. Usually do some extra boxes that you don't shade in for float time. So let's start our Gantt chart. I'm just going to go down the way, but you can go up the way if you want. So we've got A, B, C, D, E, F, G, H, I, J. So you need to draw some boxes, so you need to constantly check your table. Starts at 0, takes 3 hours. I've already pre-prepared some of these, so you'll need to get a ruler and draw these, but there's 1, 2, 3 hours for A, starting at 0. B starts at 3 and takes 7 hours. So I start at 1, 2, 3. At the end of day 3, take 1, 2, 3, 4, 5, 6, 7. Just making sure I'm counting properly. Okay, C starts at 10 and takes 4 hours. So after 10, 1, 2, 3, 4. And double check anytime I want. There we go. Yep, 10 and 4. Okay, D starts at 14 and takes 1. So I know that this is 14. I have to take 1. So there we go there. E starts at 14 and takes 2. So starting in the same place for E. I'm drawing it 2 along. So there's E. F starts at 15 and takes 1. So that's 14, so that's 15. I wanted to draw it for 1. So there's 1. G starts at 16 and takes 4. So 16 and 4. H starts at 20 and takes 6. So I should be on 20 already, yep. 20. And that should be 6. 1, 2, 3, 4, 5, 6. And then we've got I, 26 for 3. So there's I. And we've got J, which is 26 for 2. So the last one starts at 26 as well, but only takes 2. So there is the completed Gantt chart.
Let's do the applications of maths, specimen paper 1, question 5. The activity network for a garden renovation project shown below. Explain using examples from the project the difference between an activity that is essential for the project and critical for the project. So we're looking for critical and essential projects. So remember, critical means there is no float time. So there's quite a few you could choose from in this question, but let's have a look to see what ones. So if you look at A, for instance, that's not critical, so that would be essential. B would be critical because it starts at 0, takes 3, and lasts for 3. C would be critical, starts at 3, lasts 4, ends at 7. 3 and 4 make 7. So any time when these two numbers add up to the end number, that would be critical, okay? So let's pick one of these critical tasks. I'll just pick critical. I'll just say C, and then we need an explanation for that. So what we're looking for here is any delays to that activity would cause a delay in the whole project's end date, okay? So it's on the critical path. And you could say something like, any delays would delay whole project. And then let's look at essential tasks. So essential is any other task. Essentially, it has to be done, but there's some flexibility in the time. So if we look at, say, A, for instance, with A, it starts at time 0, first day in other words. It should take 2 days, but it can end on day 3. It doesn't end on day 3, but it can end on day 3. So you can say an extension is needed for the project to be finished, but there is flexibility in the time. Needs to be completed, but I'll just zoom in here. Flexibility in time. And we're done there. Describe the meaning of each of the 3 values in activity C's node. So the node is just these 3 numbers here. So Looking at activity C, we've got 3, 4, and 7. So what does that mean? Well, is this about days probably? Let's just assume it's days. 3 means activity starts at the end of day 3. So it cannot start to end of day 3. What does the 4 mean? Well, the 4 means that the activity is going to last 4 days. And then the 7. So the 7 is the latest possible finish time for the activity to be completed. Latest completion time. And we can just write what that actually means, the end of day 7. And we're done there. Part C. Produce a Gantt chart for the above project. You do not need to include float times. I'll explain what happens if you had to include float times, but let's just do that now. So we can go down the way or up the way, but I'm just going to go down the way. So we're going to start with A, space B, space C, then D, then E, then F, then G, and then hopefully there's a H as well. There is. There was no H. I can delete that one then. So A, B, C, D, E, F, G. I feel like I've... Yeah, A, B, C, D, E, F, G. Okay, so we can call that label activity. Always need a label. And then we want our day at the bottom, so we'll just call that day. And we're going to go for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and so on. So now let's look at our actual thing. So for A, it starts at the end of day 0, and I was on day 1, and it lasts 2 days, so 2 boxes. So I can just draw 2 and shade in 2. Now obviously you use a ruler to be nice and neat. B also starts at the same time, it takes 3. So there we go, just shade that in. Now, talking about not including the float time. So if you look at A again, it goes 0, 2, then it says 3. So 3 is like one more box. So if I wanted to include the float time, I would draw another box and maybe just not shade it in and have a little key at the side to say that box means float. But we don't need it for this task. So let's move on to C. C says starts at 3, lasts 4. So after that one is 3, 1, 2, 3, 4. Again, using a ruler where you're actually doing this, but there you are. And then D starts at 7, takes 3. So where's it? That one there. And then E also starts at 7 and takes 2. So just 2 boxes. And then we've got F starts at 10 and takes 2. So 10 will be here after 10. Start at 10 anyway, it starts after day 10. And then G starts 9 and 1. So you need to go back 9 and 1. And there's our completed Gantt chart. So we're done there.
SQA Higher Application of Maths 2024, question 2. A college offers languages in French, Spanish, and Arabic, and it gives us all the data and we have to complete the Venn diagram. So we'll start in the middle. So 31 students study all 3. So that goes right in the middle. And then we work on the middle out the way. So let's look for 2 things. So 15 students study French, 51 students study French and Spanish. So I do French and Spanish, 51 minus 31 equals 20. 60 study Spanish and Arabic. So I do 60 minus 31, which is 29. Spanish and Arabic, 29. And then 63 study French and Arabic. So I do 63 minus 31. So that's 31, 41, 51, 61, 63, 32. And then usually, I've got 40 students studying all languages, I'll just put that in now. And then usually you're told that how many students studied French, Arabic, or Spanish, and you need to take away all the numbers in their circle. But with this question, it was actually simplified. It says French only. 34 study French only. So that's just that. I can't take away, I'll get a negative anyway. So hopefully you realise that. Spanish only is 7, so it's just 7 in the Spanish box. And Arabic only is 13, so it's just 13 up here. And there's a completed Venn diagram. Part B says a student selected at random and determine the probability if they study Spanish and Arabic but not French. So Spanish and Arabic, we're looking for that intersection again. Spanish and Arabic, 29. So it's 29 out of the total. 14 plus 13 plus 32 plus 34 plus 29 plus 31 plus 20 plus 7 is 180. So it's 29 out of the total, 180. And we'll just check that's simplified easy enough by doing the fraction button. And you can press SD a few times, and it is, or you can change that to 0.161. I think you leave it as a fraction, that's fine.
We have application of maths specimen paper from August 2023. Question 2. A group of students were asked the different types of TV shows they regularly watch. I have a comedy, reality and drama, and we've got all this information, and we have to complete a Venn diagram. So to complete a Venn diagram, you always start from the middle and work your way out. So we want all 3 in here. So 8 watched all 3. So I can put 8 in, take a little tick. And then for both, so for both drama and comedy is 14. So that is the intersection here. So I need to do 14 take away 8, which is 6. Use a calculator anytime you want. 12 watched reality and drama, so it's 12 take away 8, which is 4. And 45 watched comedy and reality, so it's 45 take away 8, which is 37. So we get them, and then we go for our singles, and this is where a calculator is probably useful. So for comedy, I've got 60, and I take away all the ones in the comedy circle, which is 37, 8 and 6. That gives me 9 for comedy. For reality, 55 watch reality, so it's 55 minus 37 minus 8 and 6. 8 and 4, which gives me 6 for reality, and drama 21, so minus 6 minus 8 minus 4 in that circle gives me 3, and then don't forget the one outside, 2. So 2 hanging about outside. And we're done there. Part B, if a student is selected randomly, find the probability they watch reality and drama TV programs, but not comedy. So we only watch reality and drama, so that's 4 students. So it's 4 out of the total. So how do I find my total? I just add up all the numbers in my Venn diagram. 2 plus 9 plus 6 plus 3 plus 4 plus 6 plus 37 plus 8 is 75. So 4 out of 75, or if you prefer a decimal, 4 divided by 75, 0.0533, but this answer is probably better, simplified fractions. And we're done there.
Application Maths 2024 question. A, an electric vehicle charging company has been awarded a contract to install 500 points in the city. As part of the contract, there's a number of tasks that must be completed, including ordering and receive a charger parts, installing an electric cable. If it is delayed, the company receives a fixed penalty of £75,000. The company has identified the following 2 reasons for a delay. You could have shortage in parts, or the electrical cables may not be in place in time. But it does say that there is a probability of 0.325 of one or both of these delays happening. Calculate the expected cost of delay. It's only worth 1 mark. So usually you're told the probability of just one of them, but now it's one or both. So if the probability of both of these things happening is 0.325, it's just 0.325 times 75,000. So we've got 0.325 times 75,000 gives us 24375. 24375. Right. The company is considered using the following control measures. Control measure 1, import parts at a cost of 15,000. Control measure 2, pay an hour firm to labour cables at a cost of 16,000. There was a 0.1 probability of shortage in parts and a 0.25 probability electric cables will not be in place. Calculate the expected cost of a delay using only control measure 1. So if I use control measure 1, start off, it cost me 15,000. So that's what I start with. And then if control measure 1 is in place, I've already imported the extra parts, so I don't need to worry about the shortage of parts, or I need to worry about the electrical cables. So I've got 0.25 times 75,000. So 0.25 times 75,000 is this, plus the 15,000 is 33,750. So only control measure 2. So control measure 2, I'll do this in a different colour so it's clear. We're using this one. That costs 16,000. And that is pay an hour firm to lay cables. So if we're laying cables, that means that this will not happen. So we don't need to think about it. So there still could be a shortage in parts. So it's 0.1 times 75,000. So that equals 0.1 times 75,000 is 7,500 plus 16,000 is 23,500, 23,500. The company will only use one control measure based on the calculations explaining which they should use to minimise expected costs. So we've already worked out the expected cost with control measure 1, it's 33,750, and control measure 2, it's 23,500. Without any control measures, it's 24,375. So to minimise expected costs, we should use control measure 2. As 23,500 is less than 33,750. It's actually also less than the expected cost if you do nothing. So there you go. Just a little note on this question. Usually it starts off with telling you the probability is 0.1, 0.25. And you need to work out the probability of both. So how you would normally do that, and they've just done it for you, is you would say, well, I've got 0.1 chance of shortage, so 0.9 of nothing happening, 0.25 the cables, so 0.75 of nothing happening. I would times them to get to 0.675. So there's a 0.675 chance nothing happens, and you take that away for 1 minus 0.675, and it's 0.325, which is exactly what basically quoted anyway in part 1. So we just did that work for you.
HB Higher Applications of Maths, Specimen Paper 1, Question 9. A TV production company is responsible for the delivery of a new quiz show to national television. If the production is delayed, the company is charged an additional £10,000. For the purpose of a cost-benefit analysis, it is assumed that there are 2 events that could cause a delay. 0.3 if a key member of staff falls ill, 0.1 for equipment failure. Now this question is saying calculate the expected value of cost should be considered for the cost-benefit analysis. It's been a bit wishy-washy here. Usually you just get told what's going to happen if one or more things fail, but let's do it based on that. So we want, what's the probability of nothing happening? Now I always do this with a tree instead of having to overthink it. So I always start off by saying, look, I'm here. And if somebody falls ill, I could say, well, ill, not ill. 0.3 if you fall ill, and then it adds up to 1, so it must be 0.7 for not being ill. And then going away again, I could have equipment failure, so failure, no fail, I'll put. And equipment failure is 0.1, which adding up to 1 again gives you 0.9 here, and you'll have the same that way. So failure, no fail, 0.1, 0.9. Now, if I wanted to know then, what's the chances of something not happening, I could work out all the things that could happen,
or just go for the option where it is fine. So the chances of nothing happening are 0.7 times 0.9. So the probability of no issue is 0.7 times 0.9, which using a calculator is 0.63. So that means that the probability of at least one thing happening, either being ill or equipment failure or both, is just 1 minus that answer because it has to add up to 1. You're either going to have no issue or you're going to have an issue. So the probability of an issue, at least 1, is 1 minus 0.63. And you can use a calculator to work that out to get 0.37. So then we can calculate the expected penalty for at least one issue. £0.37, and it says it was going to be £10,000. So times that by 10,000. Which is £3,700. So that's my cost-benefit analysis. I've worked out what happens if something bad happens. I'll get the chances are that I'll get charged in the long run £3,700. If I did it over and over again, 0.37 times, 37% of the time, something would happen. Okay, moving on to part B. It is possible to use the following control measures. Control measure 1, employ backup staff to replace someone who's ill, and that costs £1,000. Control measure 2, spend £3,000 on an equipment inspection to ensure all equipment is functioning. Calculate the expected cost if control measure 1 is taken. Well, if control measure 1 is taken, I'm automatically getting charged £1,000. Simple as that. But that means that somebody could still, no one can be ill now. Well, we're going to replace them, but equipment failure could still happen because I'm not putting any measure in place. So what's the chances of equipment failure? Well, up here it says 0.1. So I need to then add 0.1 times the expected penalty, which was £10,000. So there's my sum. So that's 1,000 plus 1,000. That's just 2,000. You can use your calculator for that. Part C, the expected value of cost of control measure 2 is taken is 6,000. They're just telling us, they're not asking us to work it out. State which control measure should you take? Well, we know that if you do nothing up here, it's expected to cost you £3,700. But if you take control measure 1, it's going to expect in the long run to be 2,000, and control measure 2 is 6,000. So it's obviously the cheapest one, isn't it? So control measure 1. And we need to support our recommendation because it is the lowest expected cost, not the lowest cost. If something happens, you're paying £10,000, but the lowest expected in the long run. Lowest expected cost. And we're done there.
This has been Clear Maths. Hope you found this useful. It's went through every single topic, question by question by question, for the maths exams in 2025. Take care, stay safe, and goodbye. Application Maths 2024 question 6, and this is a spreadsheet question on Q6 Golf. A golf ball manufacturing company has designed a new golf ball which is more hard wearing. We want to determine if there's a difference in the distance travelled by current and new. To measure distances by current and new, a random sample of 40 were produced and subjected to a test, and they collected the data for distance travelled for both current and new. The data was found to be approximately normally distributed. Generate and state the appropriate measures of location and spread for current and new golf balls. So if it is normally distributed, you can use the mean and standard deviation. If there's a skew, you use the median and interquartile range. Make two valid comparisons about the driving distances of both current and new golf balls, so we can look at that when we get our mean and standard deviation. And then state appropriate null and alternative hypotheses. Do a hypothesis test, interpret a p-value. So we'll get to that when we get to that. Let's look up RStudio, because it's an RStudio question. So I've already loaded it in, and you're going to need the data booklet. So let's just get the data booklet ready. Okay, so there we go. So first thing we do is data booklet is my data read.csv. My data read.csv, and then it's called Q6 golf.csv. Just make sure you've done that correctly by checking my data, read.csv, yeah. Control Enter to run, and then attach my data. Okay, so we want mean and standard deviation. So I'm going to just split this into two. You would have a data book usually beside you. So I'm looking for, let me just unzoom this a little bit, descriptive statistics. So we don't want a summary because that's mean and median. We want the mean and standard deviation. So we'll just do it separately. So we need to know what the headings are called. So you can just click View File. We've got current and new. Great. So back to this. We want mean of current. Should come up. We want standard deviation of current. And then we want mean of new. And we want standard deviation of new. So we get all that. So let's just copy that over to our Word document, statistical software output, mean, standard deviation. And is that everything we have to do? Generate appropriate locations of location spread. Yeah. Make two valid comparisons about the driving distances of both current and new golf balls. So let's just put this in. Measure of location, meters, measure of spread. So location is the average, so it's 270.28. And the spread is 8.75, say. And then for the new one, it's 267.5. And the spread is 9.89 or 9.90. Any rounding you want. And then on average, using the mean, current golf balls travel further. 270.28 is bigger than 267.5. And then measures of spread. The distances travelled by current golf balls is more consistent than new golf balls. And that's because 8.75 is bigger than 9.90. Or you could say the distances travelled by current golf balls is less spread out. Or the distance travelled by new golf balls is more spread out or less consistent. Okay, next question. The appropriate null and alternative hypothesis to determine if there's a statistically significant difference between the distances travelled by current and new golf balls. Okay, it's null. Let's look at a null hypothesis. There is no difference between the distances travelled by current and new golf balls. Alternative hypothesis. There is a difference between the distances travelled by current and new golf balls. Part C. State what type of hypothesis test appropriate to determine if there's a statistically significant difference between distances travelled by current and new golf balls. This can help you if you want. It's a t-test. Performs a two-sample t-test between two separate sets of data. It's not paired. It's just a normal t-test because they're independent of each other. So it is just a t-test. So we just type in t-test. And I've put my null and hypothesis, alternative hypothesis in the correct place. Now it says, perform the test, state the p-value, interpret the p-value. So let's go back to RStudio, t.test, and it was called current, and it was called new. Pretty sure that's how you do it. Control Enter. So we get our Welsh 2-sample t-test. We can copy that over as a statistical output. And we want the p-value. There's our p-value there, 0.188. Interpret the p-value in the result of our hypothesis test in context. So, since the p-value of 0.188 is greater than 0.05, you fail to reject a null hypothesis. If it's less than 0.05, you can reject a null hypothesis, but if it's greater than, you cannot reject it, but you can't say it doesn't there. So you've failed to reject the null hypothesis. And what was our null hypothesis? That there was no difference in the distances travelled between new golf balls. So if we were rejecting the null hypothesis, we would say that we can accept that there's probably a difference between current and new golf balls, but since we're failing to reject the null hypothesis, we cannot determine if there is a significant difference between the distances travelled by new and current golf balls from this data. And that's that question done.
Down here for Clear Maths, SQA, Higher Application of Maths, 2023, question 5. This is the spreadsheet file Q5 Coffee, where you have to construct a scatter plot of number of calories on carbohydrate content. So number of calories is a Y, carbohydrate content is the X. If you do a scatter plot, I usually use RStudio, I'm presuming you do too, and the data booklet is going to be handy for this. So let's go to the data booklet now. There is a data booklet for helpful R commands. The first one we need are my data and attach my data. Now I'm going to type this in, but you can actually copy and paste these as well, which is really quite handy. But I'm going to type them in case copy and pasting doesn't work for you anyway. So let's go to our Studio, which I've got it on the cloud, but you might have had it downloaded, same kind of thing. You find your file on your computer and get it into our Studio first of all. And the first thing you're going to do is your my data. So my data up in the terminal, /- and it's read.csv, and then open brackets, inverted commas, Q5 coffee.csv, inverted commas and brackets, and then Control Enter to do that command. Now we need to do attach. So it's attach my data in brackets and enter, and that's us done our attachment. So now we need to plot our scatter plot. So you go back to your data booklet and go down to graphics, and you're looking for the one that says produce a scatter plot. So it's this one here. Okay, so let's go into RStudio and type that in, replacing the X and the Y, of course, with our variables, which are carbohydrate content on the X and number of calories on the Y. So plot, and then it's XY. So X is number of calories on carbohydrate content. So you write carbohydrate content first, carbohydrate.content, just click it, comma, number, just start typing it, and it comes up of calories. Name the x-axis, xlab equals inverted commas. So X carbohydrate content, and we're going to put our units of grams in there, and then comma, y lab equals, inverted commas again, number of calories. And we're going to give the units of that, which is kilocals. Okay, the next stage is to get our title. So to get our title, we put comma, space main equals scatter plot of number of calories on carbohydrate content. Now the last bit of the command, we have got PCH equals 21 and we have got BG equals inverted commas black. Make sure everything's closed up properly with inverted commas and brackets and press Control Enter. And you'll get a nice scatter plot of number of calories on carbohydrate content. That's got our 2 marks. Part B. Find the correlation coefficient between the number of calories and carbohydrate content. And the data booklet is helpful for anything like this. Back to the data booklet, down to correlation and regression. The core test tells you the correlation coefficient. So it's core.test xy, nice and simple there. So back into here, core.test. X is carbohydrate content. So carbohydrate content, comma, number of calories. Control Enter. And we get an output. Interpret the correlation coefficient. Okay, so let's copy this into our answer sheet. Well, there's our answer sheet there. You can just copy your scatter plot, and then part B, your statistical output, that is our Pearson's correlation coefficient. We can put that there. We can write our actual answer, 0.9628262. You actually write the answer. It's checking you understand not to use any of the other values there. It's the correlation coefficient you're looking for. And interpret the correlation coefficient. Well, the correlation coefficient is close to 1, so we can say that it has got a strong positive linear relationship or association between carbohydrate content and number of calories. So let's just write something like that. There is a strong positive linear association or correlation between carbohydrate content and the number of calories. Part C of this question, find the equation of the regression line of number of calories on carbohydrate content, interpret the slope and intercept parameters. So back to data booklet for a regression line. We have got the second command here fits a linear regression line to the data. LM y tiddle x. So back to here, LM, writing it in the wrong place, make sure you're up there, LM bracket y is our number of calories, number of calories, tiddle is shift hash on my keyboard, you'll just need to maybe look for it, but carbohydrate content, carbohydrate.content, make sure the brackets close, Control Enter, and we get a output. Let's just copy that over to our answer sheet. So there's the output. There's our output. That gives us the equation quite easily. Because if you go back to, let's go to RStudio for a moment. Number of calories is up beside and carbohydrate content's on the bottom. This tells us that the number of calories, or just calories, equals the first number plus the second number times the carbohydrate content. So we just need to write that. So number of calories, I'll just type calories actually, you'll be fine with that. Calories equals 73.65 plus 4.65 times carbohydrate. And we have to interpret what that means. So let's look at the slope first. So this is this number here, 4.65. That's what we call a gradient in maths, and that tells you that if you go along 1 on the x, you go up 4.65 on the y. So the x is carbohydrate content, and the y is the calories. So the number of calories increases by 4.65 kilocalories for every additional 1 gram or g of carbohydrate. Every time you put a gram of carbohydrate in, 4.65 calories is added. Okay, the y-intercept, or we'll just write intercept. So the intercept is the first number, 73.65. That tells you what happens when there's no x, no carbohydrate. So in a drink with 0 grams of carbohydrate, there will be 73.65 kilocalories. And that's all you need for that. Part D, estimate the number of calories in a drink with 59 grams of carbohydrate. So let's look at our data booklet. So we're going to use the predictorand to fit that in. So let's go to our studio again. We're going to use predict. Put that up here. Predict. LM. And it's y to the x. So it's number dot of calories to the carbohydrate content. And then you put a comma after the first bracket. New data equals data dot frame, and then bracket x equals c. X is carbohydrate content, so carbohydrate content equals, and by c we mean the number, so 59 in this case. And then outside the bracket, interval equals pred. So in inverted commas, pred. Make sure everything's closed, control enter, and you will get an output. Let's copy that output, shall we? It doesn't ask us for our output, but let's just put it in anyway. That was our output. And then my answer, 348.0205 offers two other numbers, but notice it says fit, lower, upper. But we pick the fit, 348 kilocal, and we're done there. We'll then just print this off for our examiner, making sure that our name and our centre number and everything else you need is in that sheet.
High Application Maths 2022 question 7. You must refer to information, strength and conditioning given the pre-release material when answering the question. You must also refer to the spreadsheet Q7 jump for this question, and we have to complete some stuff. So let's have a look. A strength and conditioning coach wants to increase vertical jump height performance in their trainees. The data in the spreadsheet file shows the back squat, weight, and the vertical jump height. We have to construct a scatter plot of vertical jump on back squat for the data. So for constructing a scatter plot, if you look at that CSV, it's just a list of two numbers. You could do scatter plots and things in Excel, but usually this is RStudio. It's much easier because you're given a data booklet. So let's do RStudio for this. So I'm in RStudio and I've already uploaded the file, which you can do yourself, and then we just use the data booklet to help us instead of actually trying to think too much. So let's find the data booklet. Helpful are commands. Well, there's the first one. We need to read the data. So if you can't remember it, easiest thing to do, copy and paste. Control C, jump into your thing, Control V, and we've got read.csv, and we just need to change the name. Excel data becomes Q7 jump, and then Control Enter makes that command go, and we can see that it's came in here, so we're good to go. Back to the data, we need to attach. So if you can't remember it, again, we can go back and Control C it, and then just jump and Control V, and there, as quickly as that, without any typing, we've attached the data. So to construct a scatter plot, so we go down to our helpful R commands and look for plot. There's plot right there. So I'll just copy that, I'll not think about it. Control C. Just notice it says it produces a scatter plot of X versus Y with black dots. So we've got plot X, Y. So if we check the question, it says construct a scatter plot of vertical jump height on back squat. So back squat is our X. So just make sure you get them the right way round. Start typing back and hopefully it'll come up. And vertical or jump. You can check the data anytime you want to see what the variable name is. X lab axis, so we want a label for the X axis, so back squat, I think it's going to be in kilograms, and Y axis label, vertical jump height, I think that'll be in centimeters. main equals scatter plot of y, which is vertical jump height, on x, which is back squat. And control enter. And there we go, vertical jump height in centimetres, back squat in kilograms. Excellent there. Next part of the question. Make an appropriate comment about the relationship between vertical jump height and back squat. So copy that, put it in here. As back squat increases, vertical jump height increases. Or you could say approximately there is a positive linear relationship between back squat and vertical jump height. Part B1, find the correlation coefficient between back squat weight and vertical jump height. So back to our thing, we need to do a core test. So if you can't remember how to do a core test, you go to your data booklet and look up a core test. Core.test it is XY. So X is our back and Y is our jump. And it gives us an output. Let's just copy that into our answers then. Statistical software output. We'll just do that there. And then our answer, we actually need to be able to interpret this. So the core test is a bit, and at the bottom it says 0.828. So we just copy this one. And we're done there. Part 2, find the equation of the regression line of the vertical jump height on back squat weight. Okay, so we're back in. We want to find the equation of the regression line. So data booklet again. Now, AB line puts the line on, but it doesn't give you the equation. It's LM that gives you the equation. So it's that one we want to copy. Y, remember, was jump. And X was back. Control enter. And we get output. Let me just copy that into our file again. So there's our output, but our answer is not our output. We need to be able to interpret this. So coefficients, and intercept is this, and back is that. So if you go back to our graph here, the vertical jump height's on the y-axis, and the x-axis is back squat. So we can say that for our answer, vertical jump height, or just jump, equals, now you can either do this number times back plus this number, or I find it much easier to do it in the order that is written in the thing. So it says 7.2366, so I'll just write that, plus 0.3593 times back squat weight. Question C. Use your statistical software to estimate the vertical jump height for a trainee who can back squat 165 kilograms. So we need to do a prediction here. So back in here, we've got predict right here. So we're going to use the prediction command. Again, back up here, change all of these variables. So jump, back, new data equals data.frame x, which is back, equals c. Now what's c? C is the number that we want for us in the question, which was 165, I believe. Yes, it was. So we change the letter c to 165. And control enter again. And we get 3 answers. Let's just copy these into our software output. So statistical software output is this. So there's a statistical software output. We now need to just answer this. So we pick the one that's fit. So it's 66.52568. So 66.5 centimetres. And we have to comment on the accuracy of this prediction. So there's 2 ways to do that. I'll give you the easiest option. The expected or fitted value is 66.5 centimetres, but the jump height is likely to be between the lower, which is 56.7 centimetres, and the upper, 76.3 centimetres. The other way you could answer this, and I'll not write this in, is you could use the correlation coefficient. If you look here at 0.828, that means there's a strong positive linear relationship between back squat and jump height. And since our 165 kilograms is within our data set, we could say that since there's a strong positive linear relationship and 165 is within our data set, it's likely to be an accurate prediction. But that's easier, just using the numbers. Based on the correlation, the coach advises the trainees that increasing their back squat weight will increase their vertical jump height. Why does the statistical analysis not support this advice? Well, we're saying that the back squat causes the jump height to be bigger. That's not necessarily true. Just because we are connected, there's a correlation, doesn't mean to say that it causes it. If you do think it does, imagine we'd done a graph here and it was number of Mars bars you eat against vertical jump height, and we got the same graph. Would we think that having eaten more Mars bars would cause us to have a bigger jump? No, we just happen to be connected. So correlation is not causation. So that's all you have to write. Although back squat and jump height are correlated, correlation is not causation. And we're done there.
We have Application Maths 2023, question 3. An online survey sent out to people by email on the electoral register who live in Renfrewshire. The aim of the survey is to determine which political party people intend to vote for in an up-and-coming election. The survey asks the following questions: state your age and years, state your gender, which political party do you intend to vote for, did you vote in the last election, if yes, which political party did you vote for in the last election, and the question is, state the type of data that best describes age. Well, ages are numbers, so it's numerical. And as it continues or discrete, well, I could be 5, but he could be 16, so it's discrete. So the word, what we're looking for is discrete numerical. 2 types of data, remember, there's numerical and categorical. Now, you could also use the word discrete and then quantitative, which means numerical, but I prefer numerical, it's easier to remember, to be honest. Right, part B2, gender. Well, gender's not numerical, so it must be categorical. Categorical. Now, you might know that the word is nominal, but you don't need to know that. Or the other word you could have used is qualitative. So you've got quantitative, which is numerical, qualitative, which is categorical. But categorical is fine for the mark. Okay, let's move on to the next bit. The results of the online survey are used to predict the outcome of an upcoming national election. Give 2 reasons why these results do not provide a representative sample of the national population to allow the prediction to be accurate. There is a number of answers possible for this question, but I'll go through the most obvious ones. The first most obvious one is this. This first survey was take place in Renfrewshire, which is just a small little place. It's nothing to do with the whole country, so it's not a national survey, it's a local survey. That's the first reason. So we could just write that. First step, it was not a national survey. But a local survey. Right, what else? Well, if we look at it, it said it was an online survey. It was an online survey. Now, can everybody access online? Maybe not everybody can get access to online. So perhaps that not all voters will be able to access the survey online. So that's another good reason. Not all voters could access the survey online. Now, what else could we have said? Well, let's check what the SQA say about this. Any reasonable answers. People could vote multiple times online. That could happen. The invite goes into junk mail. Not targeting representative portions of the voting population. But you're not, to be clear, what you can't write is things like people might not want to put their true political views online. You can't say people might be lying, but we don't know that. Or that people might change their mind, or that people might, there's a small sample size. That's not good enough. We need to be specific about this survey. It was a local survey, therefore it's not representative for national, and it was an online survey, so maybe not everybody could get access to it.
Let's refer to information on dogs and fleas for this SQA Higher Applications to Maths 2022 question 3. After study 1, the following bar chart was created. It shows the number of dogs requiring treatment for a flea infestation against the month of the year. Okay, part A, state the type of data that best describes the number of dogs requiring treatment. Okay, let me look at the data booklet for this. It's numbers, so it's something we're counting, so it's numerical. But since we're counting it, it is discrete. So it's just discrete, numerical. If it was something that you could measure or something like height, it would be continuous. The student vet claims that this graph proves that flea infestations are more common in warmer months across the UK. Why is this claim not valid? So let's look at the actual data booklet for this. So the UK is a nation of dog lovers with 1 in 4 adults owning a dog. Owning a dog is a big commitment. It's important that dog owners need the needs of a dog, so register them with a vet. One thing a dog owner needs to be aware of is fleas. Fleas are blood-sucking parasites. Fleas are found throughout the year and are believed to be more common in warmer months. They are thought to be more common in rural areas. A dog is said to have a flea infestation when it has more than 20. Study 1. To investigate the seasonal variation of flea infestation in dogs, a student vet on a placement in a veterinary clinic in Edinburgh City Centre gathers data on the number of dogs requiring treatment. From appointment records, the number of treatments for flea infestations in the dogs over a 1-year period were recorded. Seems good enough for a whole year. But where we did it? Only in Edinburgh. So watch out for that. So if we go back to our question, it says the student vet claims that flea infestation are more common in warmer months across the UK. Well, if we look at our graph, definitely more common in warmer months, but this is only a local study, so it doesn't tell us anything about the whole of the UK. So that's all that we can say. One clinic in Edinburgh is not representative of the UK. And there we are. You could also say just that the claim cannot be made from a graph. The data gathered for study 2 is shown in the table. So we've got area, number of dogs inspected, number of dogs with a flea infestation, urban, rural, and then just the totals here and here and here. State a statistical test that would be appropriate to determine whether this data provides evidence of difference in flea infestations between urban and rural areas. There is only one test that is appropriate for categorical data, which is what this is, and it's a z-test. So that's our answer, z-test for 2 proportions. So basically what you would be looking at is the fraction that had infestations. Let's have a look at sample 2. Another study in the sample of dogs was inspected for flea infestations over a 3-month period at an Edinburgh clinic, and a similar sample was inspected at a rural veterinary clinic. So the 2 different places, that's excellent. State 1 part of the design of study 2 that would need to be valid to make sure the tests are valid. Well, make sure it's a random sample of dogs. So samples chosen randomly. To fit in with the student vet's placements, the data from the urban clinic was collected from July to September, and the data from the rural clinic was collected from October to December. How this might affect the conclusions of study 2. The conclusions, of course, will be valid because it's not a comparable time period. That's all you need to write. Conclusions won't be valid as not comparable time periods. And we're done there.
So Maths 2024 question 4. You must refer to the pre-release information on Dracania plants and carbon dioxide levels. Let's read it first though. You've got to fill in a spreadsheet and complete it in the answer space provided. In fact, if I tutored you, you'll realise that I predicted that this would actually be the question. It's exactly the same question I told you it would be. So a research scientist is studying the effect of Dracania plants to improve air quality. Large ones reduce by 13% in the showroom, and each evening the heating's left on and it adds CO2 to increase it by 180. At the start of the study it's 2000. Complete the worksheet to estimate the CO2 at the end of 30 days. And here's the worksheet. It's already filled in some of these boxes for you, but you need to fill in some more. But let's look at the pre-release material and make sure we don't miss anything. So there's the pre-release material. It just talks about the type, what these plants do, reduce CO2. It says they're used to try and improve levels of CO2 levels. They're measured in parts per million. And it says the acceptable levels in the UK are 800 for very good air quality, below 800, and above 1500 is poor air quality. When it's identified, control measures need to be taken to improve ventilation. Okay, so let's go to our spreadsheet. Starting with 2000, it's reduced by 13% from the plant, so we need to work out what's left. So to work out what's left, it's just equals 1 minus that box if it's been set up correctly. Yep, 87%, or check your calculator. And then additional levels emitted by the heating system is 180. We have to do it by the end of 30 days. So let's fill in a formula here. This is your recurrence relationship question. So you're doing 2000 times, and level at the end of the day, that means there's 87% left at the end of the day. So I'll put dollars around that because that's outside the box. And then we're adding in at the end of the day as well this 180. So again, that's outside the box, so we're putting dollars around that. Now, in terms of rounding, this is not money or people, so you could kind of just not round it and you would get lots of decimals, but it's going to look nicer if you do round it. And since we're estimating how much is there, I'm going to use the int command for this, because that'll just give me it to truncating it, taking away the decimal points. Or actually, let's round it. Let's round it to 2 so we can really see what's happening. Do that to start with. We can always adjust it if we prefer to adjust it later. So then 30 days, 26, 29, 30. So we've got 1394.05. I think I'm going to round that to no decimal places, I think. Or again, use the int command. And there we are. We get a nicer number, 1394. So CO2 levels at the end of 30 days is 1394. Next bit of the question says, extend your table for 60 days. Well, actually, let's read it. Research scientist investigates the long-term CO2 in the showroom. Extend your table to the end of 30 days and construct a graph to show what will happen in the showroom. I'll include titles and axes. So 30 days we've got, so we just copy it down until it says 60. And we can see it's starting to level off. We're getting the same number. So I expected that to happen, to be honest. That's what I was looking for, but maybe you didn't. Insert recommended charts and just pick one that looks good. Don't pick one of these bars, that's not going to help. But one of these is fine. You've either got the scatter or the line. Or if you don't go to insert, you can just go here and click charts and then just click scatter and pick the one that you like the look of. So there we get our scatter. Let's just move this up so we can see it next to the table better and we can work on it. And let's make it a little bit bigger. So, title, CO2 levels at the end of each day in the showroom. And then we need to add our axis labels. So, axis titles, CO2 levels in parts per million. I'm going to make that too small just because it is a subscript, but you probably won't have to do that. And then this one is just day or end of day. And there you go, we've got a nice graph. Part C, explain whether Dracaena plants are effective at obtaining very good air quality in the showroom. Well, you can see it levels off at about 1300, 1388 here. And to get very good air quality, you need it to be 800 or below. So no large Dracaena plants are not effective at obtaining very good air quality in the showroom, as CO2 levels will not go below around, what do we get? 1388 parts per million in the long term, and 1388 parts per million is greater than 800 parts per million. And I think that you'll be fine with that. So let's see what else to do with this question. Just print it in value and formula view. So you just go to File, Print, that's just value view. You have to make sure that your graph is beside the table and on one page. So fit on one page, which I've already sheet on one page, that's fine. And then if you want formula view, you go to Formula, Show Formulas, File again, Print, and you can see it on Formula View there with all the formulas shown. And that's done for that question.
SBI Applications of Maths 2023 question 8. You must refer to the spreadsheet file Q8 warehouse when answering this question. Complete parts A and B1 using the spreadsheet file. Parts B2, C and D must complete in the answer space below. Okay, and I'll just put it on a file for us so we can see the answers. It says, a warehouse company currently has 1750 units of stock. They deliver 20% of our current stock each week and receive 300 units of new stock per week. Complete the warehouse stock to identify the cell in C10. We predict the number of stocks in the warehouse at the end of week 26. Okay, so here's the spreadsheet file. So percentage stock remaining at the end of the week. Well, we delivered 20%, so that means we've got 80% left. So I'll just set up to be a percentage, so we can just press enter. And the number of new units of stock per week, they said, was 300. So we need to work out what goes in this cell here. So we need a formula. So we need a formula in here. So equals, now is it an integer? Is it a whole number? What is it we're looking for? Well, it's a whole number because new units of stock, you can have like 2.5 units of stock. So we use integer for that, int. And we're going to use the one above it, which is C13. And that has to be times by. Now you can either type it in or click the box. So I'm going to click the box I want it times by 80%. So this one, but remember we need dollars. So if it doesn't give you the dollars by clicking, you need to put it in yourself. Plus, and I'm just going to type the next one, $C $9, because I don't want them to change. So just make sure you watch it for your dollars. Otherwise, you'll end up with a whole mistake. We now want to copy that all the way down. We can press Control-C, Control-V, or just highlight and pull down. So I'm just pulling it down and I get an answer. I can just type the answer in the box, or I'm just going to reference the box, which is $C $39. And that's me done part A. Part B. Extend your table in your worksheet to construct a graph to show the units of stock for 52 weeks. Using the constructed graph in B, state the type of mathematical model that describes the units of stock in the warehouse. Okay, so we have to extend the table. So the easiest way to do that is just highlight these two and pull that little corner down. And we have to go to 52 weeks. There's 51 and there's 52. So we've done that. We now need to construct a graph for this data. Okay, so we're going to construct a graph. So let's highlight our data. Insert. And for this one, I think we're going to want a scatter plot. So it's under here and scatter. And let's move it up so that it's somewhere appropriate. Make that a little bit bigger. Okay, we want to put our axis labels on. So axis titles, this would be number of units of stock, I suppose, at the end of the week. End of the week. And this would be weekend or end of week. I'll just put end of week. What else could we put on this? So let's see. Let's put a legend in. There you go. There's your completed graph. So that's in B part 2. Using a graph construction part 1, state which type of mathematical model describes the units of stock in the warehouse. Well, that's exponential decay. So I'm going to write exponential decay. Well, what you could have used for this is a recurrence relationship, but I prefer exponential decay for that. It says after 52 weeks, the warehouse company plans to move to a smaller building with space for 1,400 units of stock. Comment on whether the smaller building will have enough space for the stock. Justify your answer. Go back to our stock. You can see here we've done it after 52 weeks. It levels off at 1,500, so we're not going to have enough space because 1,500 is bigger than 1,400. See part 1. There will not be enough space as the number of units of stock levels off at 1,500, which is greater than 1,400. Please state one reason why this mathematical model may not be realistic. So may not be realistic because, well, what's happening? It's assuming that every single week we're going to get 300 extra units of stock. It's assuming that every single week we're going to get rid of 20% of stock. That might not be the case. It might vary. So I could just write because the number of units of stock might not increase by the same amount each week. In other words, it's not fixed. You could have also written what I said earlier, that the amount of deliveries per week might vary. In other words, it might not be fixed, but either of the two options will give you your final mark. This is print, warehouse worksheet, and value view and formula view. So for value view, you would just go straight out to print. You would make sure that it's nice and neat. Obviously, I want it on one sheet. So I want to say print active sheets. And I want maybe landscape. And I want to fit sheet to one page. Check if portrait gives you a nicer view. Either of them, portrait looks better to me. So I would print that. And then to get value view, for mine, I go to formulas, show formulas, and it shows you all the formulas you've got in there. So basically you can mark that, print again, and probably this time you'll probably want to put it on a landscape so you can see it better. But there you are, and then you just print it off, and we're done there.
SQA High Application Maths 2022, question 5. You must fit the spreadsheet, school rule, question 5. When answering this question, complete part A1, C1 using this file, and then complete parts A2, B, C2 using the answers below. So let's read the question first. A school is planning a new building and it is approaching maximum capacity. The school rule in August 2021 was 650 pupils. Approximately 18% of pupils leave by the end of each school year, and 140 new S1 pupils join the rule in August each year. We have to complete the school rule worksheet to predict the school rule in August 2031. So let's go into the spreadsheet. So you just put your dummy name in here. So Clever Maths, of course. Secure candidate number 01234556. Set a name is set a name, whatever you form. Right, let's go. The number of pupils in August 2021 is 650. And we've got 18% leaving. With 18% leaving, that means that what's left over is equal to 100 minus 18. Now you can get a calculator and work it out if you want, or just press equals 1 minus this box, and it hopefully will do it for you, 82%. If it doesn't work out for you, just get a calculator and type it in manually, 82%. Okay, S1 intake is 140. We have to work out this one, so we're going to have to go into our table. So we'll have to think about what we're actually trying to work out. If 82% are left at the end of the year, then this box is going to equal, let's just take the form first, I'll do rounding later, but it's going to equal essentially this box, which is 82%, times 650, but we don't want to type 650, we want to reference the previous because we want to do it every time, plus, and we want to add on 140 each time, so this one. Now, that's a basic version of the formula, but there's certain things we need to be aware of. If things are outside of the table, we usually use dollars because we want that to reference that cell and keep that cell referenced all the time, so that's a good rule of thumb. So what is outside of there? Well, we've got D9, so $D, $9 is what we want to put. So we can put that in, and then we've got D10, so $D, $10. And then C14 is fine because we want that to change each time. If it's inside the table, usually you want that to change each time so you don't dawdle it. So we've got that to start with, and that would be fine, but we've not rounded. Have a look at this. It's approximately 18% leave, and the number of pupils has to be a whole number. So we can just round this to 0 decimal places. You could also use the integer function if it's exact, but we're looking at rounding here, so just round. And then press enter. And we get 673, and we can just extend that by dragging and dropping, or double clicking, or copying and pasting. And we get an answer of 761. So we have answered part A. So we'll just type that in here, 761, job done. Part 2, comment on the precision of this prediction. Well, the number of pupils leaving each year is approximate. So the prediction is approximate as the number of pupils that leave at the end of each school year is approximate. And with these questions, usually when you're talking about precisions of predictions, if we go back, we look at the variables that could change. For instance, the leavers could change, but really the S1 intake, is that really 140 each year? The question says it is, but that could change too. So looking at these questions, you're looking at just making a comment on these numbers being accurate or whether they can change or not. Part B, comment on the relationship between time and predicted school roll up to August 2031. So let's have a look. As each year goes on, the number of pupils increase. So that's all we'll have to write. So the number of pupils gradually increases each year. The school moves forward with plans for a new building. This will increase the capacity to 800 pupils. Extend the table on your worksheet to construct a graph to show what is predicted to happen to the school roll in the long term. You must consider what happens beyond August 2031 and then use your graph to determine whether the new capacity is suitable. So let's go back to our graph. We need to extend our graph so we can just highlight and we can start dragging down and just see what happens. Well, this looks like it's still increasing, so I'll keep going. See if there's any actual, there's a pattern there. So have a look there. We can start to see that it is given as the same number. Do that a few more times just to check. And generally speaking, with a question like this is what you're looking to happen. So we get that. And then we have to make a graph. So let's highlight all the data and don't give ourselves a headache. Insert, recommended charts. Top one looks good. So I'll just press OK. And I'll move that up so that it's in an appropriate place. And let's just make sure the axes are labelled. So graph of number of, well, let's just call it school roll against year. That seems good. So a title for a graph, and then axes, so plus axis titles. This one's number of pupils. And this one is year. So we've appropriately labelled our graph, just in case there's a mark for that. Now in this question there wasn't a mark for that, but there will be a mark for it somewhere probably. So just make sure all graphs are appropriately labelled whenever you do them. Okay, so we've done a graph. Let's go check the question. Extend your table and construct a graph to show what's happened to the school in the long term. Well, we've done that. So there's your 2 marks. We've extended the table with the constructed graph. We've made sure that it does something that levels off and we go far enough. If in doubt, go too far. Don't do too little. Use your graph to determine whether the new capacity is suitable. So the new capacity is 800 pupils. Well, where's my graph there? Now this is an exponential graph. And you can see that it's going up and then levelling off. Or you can see that in the table it's levelling off at 776. Now the capacity is 800, it says. So for part 2, yes, the capacity of 800 is suitable as the number of pupils levels off or never exceeds 776. And that will give you your mark there. And then it says to print the school worksheet in value view and formula view. So value view and formula view on one page. So just to click, this is a value view. So we just go to File, Print, Fit Sheet on one page, and then you'll get it all on one page. So that's value view. But for formula view, you go to Formulas, and you go to click here, show formulas, and then it will show all the formulas that you've used so that SQA can mark it and make sure you've rounded. File again, print, make sure you click to fit on one sheet, which is done, and then you just print it and away you go. Just a little note on this. We may ask you, it's come up before, we'll just get rid of these formulas. This graph is called an exponential graph. So this is called exponential growth. If it goes down the way, it's called exponential decay. The other thing you could call it is a recurrence relationship. This is actually doing a recurrence relationship because it's using the previous value to get the next value over and over again. And that's done for this question.
So SQA, Higher Applications of Maths, 2023, question 1. A school year in Scotland usually lasts 190 days. Estimate the number of hours a typical pupil in Scotland will spend in school during their lifetime. State any further assumptions you make. Okay, so we need to assume how many years a pupil in Scotland is at school. So let's take primary school, that's maybe 7 years, high school up to 6 years, 7 and 6, 13 years say, some maybe a little bit less, some maybe a little bit more. So we're going to assume, we need to assume 13 years of schooling. Now, we're quite generous with this one. As long as you say something between 11 and 15, you'll be fine. A reasonable assumption. Now, what about the number of hours that we're at school? Well, maybe our school starts at 9 and ends at about 3, maybe half 3, 9, 10, 11, 12, 1, 2, 3, 6 hours maybe would maybe be reasonable. So assume 6 hours per day of schooling. And again, they're quite lenient with this one. Anywhere between 5 and 8 would be okay with this. Okay, a reasonable assumption. Okay, so now we need to estimate the number of hours that the pupil spends in school. So we've got 190 days a year times 13 years of schooling times 6 hours a day. So there's the sum I need to do. Getting a calculator for all that, and never you don't do anything without a calculator for this exam. 190 times 13, 13 times 6, 14, 8, 20 hours. And again, this question is, there's a range of answers that is reasonable, okay? As long as your first assumption was between 11 and 15 years, and your second assumption between 5 and 8 hours, and you do 190 times your years times your hours to get the total, you'll be fine there. There's worth 3 marks, 2 for the assumptions and 1 for your final sum.
Question 1. Estimate the number of hours sleep a typical person in Scotland has during their lifetime. So this is a Fermi estimate. So I need to assume how many hours sleep. So I write assume. Let's just go for the standard 8 hours per night or day. And we're going to need to assume how long they live. So assume they live 75 years, seems reasonable. And we're going to also assume 365 days a year, just to avoid the leap years. So then we just do 8 times 75 times 365, 219,000. 219,000 hours. Just look at them asking for question 1. Since it's a Fermi estimate, you've got quite a leeway. 6 to 10 hours a night, as you could have used anywhere between 65 and 90 years for the number of, anywhere between 65 and 90 for how long you live. You have to use 365 days or a suitable number of weeks, and then your times. Obviously, I've done the same as the SQA, 8 times 365 times 75, but you might have a different answer depending on the number of hours, years you used. Just make sure it wasn't outward that range. And we're done there. Okay, SQA Higher Application Maths 2022, question 10. You must refer to information mountain gorillas given in the pre-release material, so we'll look at that in a minute. The 2020 study found that the population of mountain gorillas has increased to 1,004. And an expert has stated that if the mountain gorilla population in Virginia mountains continues to go exponentially, there will be 1,600 by the year 2032. Determine if he's correct. So we're going to have to look at this pre-release material to see if there's any information to help us with this. It says deforestation happened on a massive scale, blah, 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 blah. A study in 2008, starting on this paragraph, said there was only 680 mountain gorillas in Virginia mountains. A study in 2020 showed that due to conservation efforts clamping down, that had increased, and we know what that's increased to. And we'll come back to this a little bit later for the rest of the question. But we do know that in 2008 there was 680. 2008 there was 680. We know in 2020 there are 1,004. Now the way exponential growth works is if over a certain time period, like 10 years, something had doubled, it will keep doubling every 10 years. So this is 12 years and we now want to know 2032. So let's just check that time period is the same, 12 years, 12 years. So if I know what that's times by, for the next one I'll just times by the same amount. So how do I know the multiplier? I just do 1,004 divided by 680. That's 1.476. I'll take a note of it as a truncated amount, but I'll just leave it in my calculator. So that means to get to the next one, I'm going to times by 1.476 as well. So I'm just going to times 1,004 by that. So I'm just going to press times 1,004. That gives me 1482.376. So that's about That's about 1482. Just rounding down because it's a whole number of gorillas. So that means that the expert is wrong because 1482 is much less than 1600, and for exponential growth to occur, 1482 must be the number. Adult mountain gorilla eats 30 kilograms of food per day. Estimate the amount of termites and ants in kilograms that a typical mountain gorilla will eat during their adult lifetime. State any assumptions you make. So this is called a Fermi estimate. So we're looking from the second paragraphs. Mountain gorillas are considered adults when they're 10 years old and live an average of 35 years. So there's a trick. It's not 35 times by, it's 25 because they're adults when they hit 10. And the second trick, mountain gorillas survive mainly on a vegetarian diet consisting of bamboo shoots, fruits and berries. Given the opportunity, they will also eat ants and termites, but the diet will remain mostly vegetarian. So what does that mean? Well, if you're mainly or mostly something, it means you eat more than, or do it 50% of the time or less, more. So if you're going to pick the amount of termites or ants that the gorillas eat, you have to pick a number less than 50%. So we're going to assume they live, adult life is 25 years. We're going to assume the usual that there's 365 days per year to get rid of the leap years. We've got that. We've got to estimate the maximum amount of termites. So the maximum will have to be less than 50%. So what's the closest to 50%? We could be 49.99% or 49%. I'm going to assume 49% of termites per year. Now it has to be 49% because it's the maximum we're looking for, so it's not just any old. So then we're just going to do 49% of 30 times 365 times 25. So 0.49 is 49% times 30 times 365 times 25. 134,137.5. That's about then 134,000 kilograms, thereabouts. The data, if you look at it, is given to two significant figures, 1600, 1004. So 134,000 is reasonable, but you'll get an answer for anywhere between 130 and 140,000 as long as you've rounded it somewhere reasonable. But the key point of this question is 49%. SQA Higher Application of Maths 2023 Spec Paper, August. Question 6. The three diagrams below show a parachute's height varies above the ground over a period of time. So you've got A, B and C. Which graph can't mod over jump? So if you jump out of a plane, you're always going down. You never jump back up. It might look like it does in the movies because it's getting filmed by someone falling, but actually you always just go down. So that goes down all the time, that goes down all the time. This one goes down and then seems to jump up, so it's B. B, height cannot increase during parachute jump. And we're done there.
SQA, Higher Applications of Maths, 2024 question 10. A factory fills cans with carbonated fruit drink. The cans can have a volume of 330. The graph shows the relationship in time in seconds and the volume of carbonated fruit drink in milliliters as a can's filled. State the type of relationship modelled in the graph. Well, it might be hard to see this, but there's just a bunch of dots going in a line. There we are, I'll just draw it in for you. And therefore, that is a linear model. You get three main types of models at higher apps: linear, quadratic, and, well, exponential. And linear is a straight line. So we're done there. Determine the rate at which each can be filled with carbonated fruit drink. You must include units. So rate is the same as gradient. I want to know how much milliliters per second. So I'll pick a point that I can read. So 1 in the corner, that one's good. Well, that's good, it lines up with 1. And make sure you get this really right. It is not 100, but it's going up in 10, 20, 30, 40, 50. That's 110. So really the rate is 110 over 1. If you picked a different point, you would have to divide. You could have picked 220 divided by 2, or the last one, 330 divided by 3. But you'll still get 110. 110 divided by 1 is 110. And the units are, it's milliliters and it's seconds. So milliliters per second. And we're done there.
So a factory can only fill cans when staff are present. The machines in the factory can fill 5 cans at the same time. How many cans can it fill in a week? Stating the assumptions. So it's a Fermi estimate. So let's make some assumptions. So I'm going to assume factory open 5 days a week. You might assume 7, you might assume 3. I assume a part-time factory, but 5 seems reasonable. And we're going to assume staff work 8 hours per day. Now you might have assumed 24, you might assume that 24 factory, but 8 hours seems reasonable. So then it can fill 5 cans at a time. So we need to work out how much cans it can fill in all that time. So looking at our information, a can is 330 milliliters, and we know the machine for 1 can does 110 milliliters per second. So if we've got 330 milliliters and it's 110 milliliters per second, that takes 3 seconds for 1 can. But it's actually, it can do 5 cans at the same time. So it takes 3 seconds for 5 cans. So if it's 3 seconds for 5 cans, well, how many minutes, seconds are in a minute? There's 60 seconds in a minute. So 60 divided by 3 equals 20. So it can do 20 times 5, which is 100 cans per minute. So per hour, 100 times 60, it can do 6,000 cans per hour. So now we just times everything together. 6,000 times 5 days a week times 8 hours a day is 240,000 cans. And we're done there.
SQA Higher Applications of Maths, 2023 question 10. We must refer to the information E10 in the pre-release material, which I've got downloaded. It says at the end of June 2021, the UK government replaced the standard E5 fuel with E10 to reduce national CO2 emissions. A newspaper article stated that since the nationwide introduction of E10 fuel, CO2 emissions have reduced to the effect of taking 550,000 cars off the road by the end of 2022. We have to calculate the CO2 emissions of 550,000 cars. So let's have a look at this. There's a data we've got at the side here. There's the E10 petrol. And CO2 is one of greenhouse gas contributors to climate change, and the main benefit of E10 is it reduces it. By blending petrol with up to 10% ethanol, less fossil fuel is needed, helping us to reduce carbon emissions. The introduction of E10 in the UK is predicted to cut CO2 emissions by 750,000 tonnes a year, equivalent to 350,000 cars. So there's the bit of information we need. 750,000 tonnes is equal to 350,000 cars. So let's get rid of that for now. So we need to work out 550,000 cars. So we just do 750,000 divided by 350,000, because that will give us one car, and then times 550,000. That's a calculator job, that one. 750,123 divided by 350,123 times 550,123 is equal to 1178571. 0.428. We'll just truncate that to 1178571 tons. That'll be fine. Or 0.4 or 0.43. Okay, next one. Suggest a reason why the information from a newspaper article might not be appropriate as part of further research on reducing CO2 emissions. A number of things here. You can say that the newspaper article might be biased. You can say the information in the article might not be accurate. You can say other factors affect CO2 emissions, but fuel might change or cars might change. There's lots of things. But you could say, the thing you can't say, and this is very, very clear, is that you can't say that the information in a newspaper article is not accurate. You can say it might not be accurate, but you can't say it's not accurate. So I'm just going to put one of the reasons down. I'm going to say the newspaper might be biased. What I'm using, might not is biased. We don't know it is biased, but it might be. The fuel economy of a car, F miles per gallon, is reduced when it carries an additional load of M kilograms. The fuel economy of small cars modelled using the following equation. F equals 73.6 times 0.98 to the power of M over 42. State the independent variable. Well, a variable is something that can change. So the numbers are not variables. These are just numbers. They are constants. So the independent variable here is just this M. That's the thing that changes that affects the fuel economy. So M. Estimate the fuel economy of a small car that's carrying an additional load of 150 kilograms. F, remember, is equal to this formula. So I'll just do 73.6 times 0.98 to the power of 150 over 45. Use my calculator. $150 over 45. You get 68.806. 68.806. So 68.8, and then the units were miles per gallon, so we need to put our units in. All done for that bit. A customer is filling up their tank with petrol. The shape of the petrol tank inside the car is a horizontal cylinder with two hemispheres on either side, shown in the diagram. We'll go to depth of petrol as it goes through this tank. The three diagrams show how the depth of petrol varies with the volume of petrol in the tank. A, B, and C. Explain which graph could model the petrol in the tank. So to work out what graph this is, well, we can see here, if you look at the picture of the tank, as this is getting filled up with liquid, since this is changing like that, it will go in fast to start with, but it will start to slow down as it gets to the middle because it gets to its widest point. So it will go in fast and start to slow down, but once it gets to the middle, since this is symmetrical, the width is actually decreasing as you get to the top. So it will start to get faster again once you get past the middle. So it will go in fast. Once you start slowing down, then go in fast again. Going fast, starts, slows down, goes in fast again. Compare that to B. That's going in slow, slower, 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 and then going fast. That doesn't make sense. It doesn't go slower, slower, slower. It goes in fast, starts to slow down. And then this one, graph C, going in fast and then steady. If it was steady, it means the depth wouldn't change, the width of this container wouldn't change at all, which isn't true, of course, because it's changing constantly. So it's graph A. And all we need to do is explain exactly what I just said. Graph A, because at start, depth increases faster, then slows in the middle,
then depth increases faster again at the end. And we're done there.
This has been Clever Maths. Hope you found this useful. It's went through every single topic, question by question by question, for the maths exams in 2025. Take care, stay safe, and goodbye.